Hello there and welcome to Life Beyond Seen, where curiosity takes the scenic route through science and wonder sometimes hides in the quiet corners of the world. Tonight, we're not gazing at the stars or the ticking of time. We're going somewhere far colder, darker and quieter. A place almost no one has ever seen, and fewer still have dared to imagine in detail. It lies at the edge of the Atlantic, beyond the familiar maps, where the ocean drops into a black wound in the earth. It's called the South Sandwich Trench, and it might just be the most forbidden abyss our planet has to offer. You can think of it as the Atlantic's deep secret, an underwater scar so far from everything that it's easy to forget it exists. Most people haven't heard of it at all. Even oceanographers sometimes pause before remembering where it lies. If you picture the world map in your mind, run your finger down the curve of South America, past Argentina, past the Falklands, and then keep drifting east into nothing. There, in the cold southern waters, just north of Antarctica, a string of volcanic islands called the South Sandwich Islands rise like teeth out of the sea. To the east of those islands, the seafloor drops away so abruptly that it's as if the earth itself inhaled and never exhaled again. That's where we're going tonight. Before we sink into that silence, though, I wonder where you're listening from. Maybe you're somewhere warm, wrapped up against the hum of the city, or maybe you're lying in the dark, letting your thoughts slow down while the sound of my voice moves around the edges of your mind. Either way, it's a good moment to pause, take a breath, and let the idea settle in that there are still places on this planet that remain almost completely untouched. If you find these quiet journeys soothing, if drifting into these unseen corners of the world feels like a small escape from the noise of everything else, I'd be grateful if you gave this video a like, maybe even subscribed, so this little space of calm can reach others who might need it too. Now, let's begin our descent. The South Sandwich Trench isn't famous like the Mariana Trench. There are no record-breaking expeditions plastered across headlines, no iconic photographs of submersibles disappearing into its depths. It's quiet even in history. That's part of what makes it fascinating. It's an enormous geological feature, yet it hides almost completely from human attention, as if it prefers being left alone. And maybe that's fitting, because everything about it resists human presence. The temperatures are near freezing, the pressure could crush a submarine like a tin can, and the isolation is so complete that even data transmissions struggle to reach the surface without distortion. Imagine you're standing, or rather, floating, above it. The water is steel blue, heavy with the kind of stillness only found far from shore. The islands nearby are mostly uninhabited, covered in glaciers and volcanic rock. The air smells like salt and ice, and the wind carries the kind of emptiness that makes you instinctively whisper. Beneath you, the ocean floor falls away for nearly 8.5 kilometers. That's deeper than Mount Everest is tall. It's not just a drop, it's a plunge into a world where light ceases to exist, and even the simplest sound travels strangely, slower, heavier, like it's unsure whether it should keep going. Scientists once described the trench as a place beyond comfort, which feels like an understatement. Down there, the pressure reaches around 800 times what you're feeling right now at sea level. To survive at that depth, you'd need to be built entirely differently. Your body, your bones, your cells, every part of you would have to adapt to a crushing world. The fish that live there have no gas bladders. Their flesh is gelatinous, their bones soft, their existence a quiet defiance of physics. And yet, in the dark, they drift calmly, feeding on whatever falls from the brighter world above. Down there, a fragment of dead jellyfish is a banquet, and patience is the only way to live. It's strange to think that somewhere on this same planet, while people are scrolling through screens or falling asleep, there are creatures suspended in that slow, crushing blackness, living lives utterly removed from ours. The South Sandwich Trench reminds us that the world doesn't end where our curiosity does. There's always another layer waiting beneath what we call familiar, and sometimes that layer is deep enough to erase everything we recognize. What makes this trench particularly mysterious isn't just its depth, it's how hidden it's been. For decades, very little data existed about it at all. The southern Atlantic is notoriously rough, and those remote islands are surrounded by some of the most treacherous seas on Earth. Getting a ship there takes planning, luck, and a certain willingness to accept that things might not go as intended. The weather can turn violent in minutes. Icebergs drift silently through fog. Even in the age of satellites and GPS, that stretch of ocean feels stubbornly untamed. When researchers finally managed to map the trench with modern sonar, they found it to be far deeper and more complex than expected. A series of steep slopes, ridges, and basins folding into each other like wrinkles in the skin of the planet. It's almost poetic how the Earth hides its most impressive features in places no one looks. The South Sandwich Trench was formed by the slow grinding movement of tectonic plates. The South American plate sliding beneath the smaller South Sandwich plate. This subduction zone has been active for millions of years, a constant slow-motion collision that forces one piece of Earth's crust to dive under another. That's what creates the trench, a scar carved by planetary motion. Above it, the same forces give rise to volcanic islands, each one a vent where the planet exhales its heat into the icy air. It's geology at its most dramatic, but hidden under thousands of meters of water. When you think about it, that's what the ocean really is. A veil. It hides not only creatures and currents, but whole landscapes. There are mountain ranges taller than the Alps, volcanoes, valleys and plains, all invisible to us because they're buried under salt water. The South Sandwich Trench is one of those hidden worlds, a reminder that our maps are more like polite guesses than complete truths. What's interesting is how late we came to even acknowledge this part of the Earth's geography. The trench wasn't measured in full detail until the late 20th and early 21st centuries. Before that, it was just a faint contour on nautical charts, a line marking very deep water. The name itself comes from those distant islands, which in turn were named after a British noble in the 18th century, Lord Sandwich, of the same lineage that supposedly gave the world the lunch staple. It's a small, odd human echo attached to one of the least human places imaginable. Somewhere, between the polite absurdity of names and the silent immensity of the deep, there's a certain charm. If we were to descend together now, past the surface chop, you'd notice how quickly the light fades. Sunlight doesn't last long in the open ocean. Within a few hundred meters, everything turns blue, then navy, then a total absence of colour. The temperature drops rapidly, the water thickens, and sound becomes the only sense that still works reliably. You can hear the distant creaks of icebergs breaking miles away, the faint hum of tectonic activity, even the echo of whales navigating through the water columns far above. But deeper still, around 6 or 7 kilometers down, even those sounds fade until all that's left is the vibration of your own heartbeat transmitted through your bones. That's the kind of silence that lives down there, not empty but absolute. It's not the silence of a quiet room or a still forest, it's the silence of the planet itself, the kind that makes you feel like a thought someone forgot to finish. And yet, in that silence, life persists. We'll explore that life more deeply later on, but for now it's enough to imagine that in the same moment you're listening, small translucent creatures are drifting through that darkness, guided by chemical gradients instead of light, feeding on flakes of organic debris that fall slowly through the water like marine snow. Each flake might take weeks to reach the bottom, swirling and dissolving along the way. It's a gentle, endless rain of carbon. Life feeding on death in an unbroken cycle that's older than language. The South Sandwich Trench may be an abyss, but it's also part of a living system. The deep ocean is one of Earth's largest carbon sinks, regulating the planet's climate in ways we still barely understand. The pressure, temperature and chemical balance at those depths help lock carbon away for centuries. In that sense, every time you take a breath, some invisible part of the exchange that made it possible happened in the dark world beneath the waves. Sometimes scientists describe the trench as forbidden, not because anyone has banned entry, but because nature itself has drawn the line. The deeper you go, the more the rules of our existence stop applying. Light doesn't behave the same way. Materials compress beyond what we can build. Communication signals falter. Even our instruments designed to withstand incredible forces sometimes come back warped or broken. It's as if the trench has its own atmosphere, its own logic, not hostile, just indifferent. There's something humbling about that. We spend so much time looking upward, mapping stars and galaxies, chasing the edges of space, and yet beneath our own feet lies a frontier just as alien. The South Sandwich Trench is our planet, reminding us that the unknown doesn't need to be far away. It can be right here, hidden in plain sight, under the same oceans that cradle our coastlines. You might wonder what draws people to study such a place. After all, there's no treasure down there, no ruins, no myths of lost cities. The draw is knowledge itself, the simple, stubborn desire to understand. Every time an expedition sends instruments into that abyss, the data that comes back changes how we see the world. New species, new mineral formations, new temperature readings that feed into global climate models. The trench might be invisible to the eye, but it's woven into how the planet breathes, how it moves, how it keeps time in geological rhythm. If you've ever stared at a horizon and felt that quiet itch to know what lies beyond it, you already understand the pull. The South Sandwich Trench is that feeling magnified, drawn out over kilometres of depth and centuries of scientific curiosity. It's the unanswered question sitting beneath the Atlantic's endless surface, whispering softly to those who dare to listen. And speaking of listening, that's exactly what researchers often do when they study the deep ocean. They listen. They drop hydrophones into the depths and record the soundscape of the trench. Earthquakes, whale calls, volcanic rumbles, even the occasional distant hum of passing ships. It's a way of mapping without seeing, of letting the planet tell its own story in vibration. In the South Sandwich Trench, those recordings capture a mix of silence and tension, the low growl of shifting plates and the slow percussion of falling rocks. It's not music, but if it were, it would be something like a heartbeat slowed to geological time. As we hover here, just at the edge of understanding, it's hard not to feel a kind of reverence for what lies below. Not fear exactly, but awareness, a recognition that the world is still much bigger than us. The trench doesn't need us. It existed long before we arrived and will continue long after we're gone. And yet, knowing it's there, existing quietly in the black undercurrent of the Atlantic, adds something to our sense of home. The same way knowing the night sky stretches infinitely outward makes Earth feel both smaller and more precious. And this really is where our descent begins. The whisper beneath the waves isn't just the sound of water and pressure, it's the sound of discovery waiting in the dark. The South Sandwich Trench sits like a folded page in the book of the planet, unread and almost untouched. As we move deeper into its story, we'll trace the contours of its creation, meet the strange life that endures its crushing depths, and uncover why this silent wound in the ocean might hold clues to the planet's past, and maybe even its future. The water is dark now, the surface far above. You can almost hear the earth breathing. The deeper you go, the quieter the world becomes, until silence isn't just the absence of sound but a presence of its own. It's not like the quiet you get in a room at night or a forest blanketed with snow. This is something denser, older, heavier, a silence that presses inward, that fills the space between thoughts, the kind of quiet where even your heartbeat sounds intrusive, where the faint click of a sonar pulse echoes like a thunderclap. Down here, sound doesn't travel the way it does on the surface. It moves slower, curved by pressure, swallowed by density. There are no waves lapping against hulls, no distant engines, no wind to carry noise. Just a dark, patient stillness that seems to breathe in rhythm with the earth itself. At a few hundred meters below the surface, the last traces of sunlight disappear. What remains is not total blackness yet, but a muted twilight, a dim blue that fades as the molecules of water absorb the shorter wavelengths of light. Within minutes of descent, the blue becomes navy, then ink, then nothing at all. The surface world vanishes, and with it, every familiar sense of direction. There's no up or down anymore, just depth. The instruments on a submersible show numbers that keep rising. 1,000 meters, 2,000, 3. Each increment marks a pressure that would crush any unprotected living thing in an instant, and yet this same world, so inhospitable to us, is filled with life forms that drift calmly through it, as if they've never known that anything different exists above. You can imagine the water around you now, impossibly still, yet constantly moving, an endless weight that presses from all directions at once. The South Sandwich Trench is one of the few places on Earth where the ocean seems to be almost motionless. Surface currents that race across the Atlantic lose their energy before reaching this far south. The cold Antarctic waters here are dense, heavy, and slow. The trench itself acts like a basin, collecting that stillness. Nothing rushes here. Even gravity feels muted, slowed by resistance. If you were to release a small object, a speck of dust, a flake of organic debris, it would drift downwards so slowly that you could fall asleep watching it. It might take hours to travel a few meters, an entire day to reach the bottom. Time behaves differently in a place like this, not because of relativity or physics in the strict sense, but because perception collapses in the absence of change. When nothing moves, seconds lose meaning. That's one of the strangest things about the abyssal zone. Movement, which defines life on the surface, wind, light, sound, heartbeat, is almost absent here. What motion remains is delicate, measured, reluctant. A transparent shrimp pulses its fins once every few seconds. A fish flexes its body to adjust position, then waits, suspended. A thin current swirls sediment across a slope at the pace of a crawling shadow. The ocean here is not frozen, but it gives that illusion. The stillness becomes hypnotic, almost peaceful, until you remember that it's born of pressure so immense that it could flatten a car into a sheet of metal no thicker than paper. When scientists first began recording sound in the South Sandwich region, they were startled not by what they heard, but by what they didn't. The hydrophones picked up only the faintest signatures, occasional tremors from the tectonic plates grinding against one another, low-frequency hums from distant icebergs carving off Antarctica, and once in a while, the mournful songs of blue whales travelling hundreds of kilometres away. Everything else was silence, an almost perfect acoustic void. It's easy to forget that silence can be informative. In this case, it tells us that very little human activity reaches this far south. There are no shipping lanes, no sonar from submarines, no constant roar of commerce. The South Sandwich Trench sits far below the routes of travel and industry, as isolated from civilization as the far side of the moon, and yet it's not untouched. Even here, thousands of meters below the waves, traces of the surface world eventually find their way down. Microscopic particles of soot, bits of plastic fibres, even remnants of pesticides have been found in samples collected from the deepest sediment layers. It's humbling to realise that humanity leaves fingerprints in places it has never physically reached. The wind, the currents, and time itself act as couriers, carrying fragments of us into the deep. A fragment of plastic from a discarded bottle can sink slowly for years, drifting through cold currents until it comes to rest on the trench floor, where it may remain for centuries. The silence here may seem perfect, but it's already learning our language. If you were to open a window in the submersible now, nothing would happen at first. Then, in a fraction of a second, everything would happen at once. The pressure would collapse the chamber, the air inside would explode outward, and the surrounding water would rush in, compressing whatever remained to a fraction of its volume. This is not violence in the human sense. The ocean isn't cruel. It simply obeys physics without sentiment. That's what defines this environment. It's beyond the reach of emotion, beyond comfort, beyond fear even. It exists in pure equilibrium, where the weight of the world above is balanced perfectly by the density of the water itself. The creatures that inhabit this zone are not survivors in the dramatic sense. They are participants in this balance, shaped by it, at peace within it. The trench doesn't destroy them, it defines them. The South Sandwich Trench is often described as alien, but that word might do it a disservice. It's not alien to Earth. It is Earth at its most fundamental, raw, quiet, stripped of decoration. This is what the planet looks like when you take away sunlight and colour, just rock, water, and pressure. And yet in that simplicity lies a strange kind of beauty. The trench walls, mapped by sonar, rise and fall like frozen waves. Some sections are smooth slopes dusted with fine sediment, while others are jagged, split open by ancient tectonic scars. In places, small landslides have occurred, leaving streaks of disturbed silt that can take decades to resettle. When researchers create 3D reconstructions from sonar data, the images look like sculptures carved from shadow, a landscape both violent and still. It's easy to romanticize a place like this, to imagine it as mysterious or haunted. But the reality is even stranger because it's indifferent. There's no malice or mythology in the abyss, only persistence. Every grain of sand, every slow pulse of water, every quiet organism follows rules written long before there were humans to interpret them. This indifference can be strangely comforting. The trench doesn't care who watches or who names it. It doesn't react to our presence. It doesn't even notice. And perhaps that's part of its appeal, the reminder that not everything on Earth exists for us to measure, conquer, or explain. You might expect that the deeper you go, the more lifeless it becomes, but that's not entirely true. The number of species decreases, but their adaptation becomes more intricate. Down here, in the zone of perpetual night, certain amphipods, tiny crustaceans resembling translucent shrimp, have been found living at record depths. Their bodies are soft, almost gelatinous, allowing them to withstand the pressure. Their cells contain special molecules called piezolites, which prevent proteins from collapsing under compression. These creatures don't fight the environment, they integrate with it. Their transparency makes them nearly invisible, an evolutionary choice that has nothing to do with camouflage from predators and everything to do with conserving energy in a place where light doesn't exist. Being unseen is simply more efficient. Further up the trench walls, snailfish have been discovered, ghostly white and flexible, moving with the slow grace of suspended thought. They don't have scales. They don't need them. Instead, they have skin so thin it ripples with every subtle change in water movement. Their skeletons are reduced to cartilage, light enough to endure what would otherwise crush solid bone. Watching them on deep-sea footage is both mesmerizing and disorienting. They don't swim so much as hover, drifting like silk in water that could snap metal. These are not monsters, not curiosities. They're quiet answers to the question of whether life can exist without light, heat, or air. And the answer, plainly, is yes. The South Sandwich Trench lies in what's called the Hadal Zone, the deepest layer of the ocean, named after Hades, the Greek underworld. It stretches from about 6,000 meters down to the deepest points known, around 11,000. Each Hadal Trench has its own personality, shaped by geography and tectonic behavior. The Mariana is deeper, the Tonga steeper, but the South Sandwich Trench is colder and more isolated than any of them. It's a world within a world, carved into the edge of a restless ocean. Because of its position near the Antarctic circumpolar current, it's constantly brushed by some of the coldest, densest water on the planet. This water sinks and circulates slowly, carrying oxygen and nutrients in a vast loop that takes centuries to complete. In that sense, the trench is both a graveyard and a cradle, a place where old water dies and new water is born, in cycles far longer than a human lifespan. The temperature here hovers around -1 degree Celsius, just above freezing. At that level, every reaction slows. Chemical processes drag on, decay becomes glacial, and movement takes on a dreamlike quality. Even bacteria metabolize at a fraction of the speed they do near the surface. A piece of organic matter that falls here, a dead fish, a fragment of plankton, might take decades to fully decompose. In that time, it becomes part of the sediment, part of the slow layering that records the history of the ocean in silence. Each layer tells a story, though no one's listening. Volcanic ash from distant eruptions, traces of iron from Saharan dust storms carried halfway across the globe, even subtle isotopic signatures from nuclear testing decades ago. The deep ocean is not empty, it's archival. It remembers everything. That silence, then, is not emptiness, it's storage. Every vibration that reaches these depths leaves an echo somewhere in the sediment, every shift in temperature a chemical trace, every tremor a small scar. The trench is like a library written in darkness, where time itself becomes the author. When scientists extract cores from the ocean floor, what they're really doing is reading those quiet pages, trying to reconstruct centuries of planetary history from tiny shifts in grain size or colour. A single core sample can hold the record of 10,000 years, each millimetre a decade, each layer a whisper of what once was. For those who study the deep sea, there's an almost meditative patience required. You can't rush data from a place where everything moves so slowly. The instruments that measure current speed or temperature gradients sometimes sit for months before transmitting a single packet of information. Deploying them requires calm weather and luck. Retrieving them requires more of the same. When the data finally arrives, it's not a dramatic revelation, but a gradual unveiling, a pattern, a subtle trend, a hint that the planet is shifting in ways only the abyss can detect first. The South Sandwich Trench, for all its silence, is a sensitive instrument. It registers the heartbeat of the Earth in long, slow intervals. And that silence becomes even more profound when you realise how fragile it is. Sound pollution in the ocean is rising worldwide. The constant rumble of ships, seismic testing and sonar mapping is changing the acoustic landscape of marine life. But here, near the South Sandwich Trench, those intrusions are still rare. It's one of the last places where natural quiet remains intact. That quiet isn't just aesthetic, it's ecological. Many deep-sea creatures rely on subtle vibrations to communicate, navigate, and hunt. A world without sound interference is a world where life still follows its original rhythm. Preserving that silence may be as important as protecting a rainforest or coral reef, because it's the baseline of what untouched nature sounds like, or rather, doesn't sound like. It's ironic that to understand the South Sandwich Trench, we rely so heavily on noise, sonar pings, pressure sensors, mechanical arms tapping rocks, all tools that disrupt the very piece we seek to study. But that's the paradox of exploration. To learn about a place, we have to disturb it. Every expedition leaves behind traces, stirred sediment, fragments of plastic tubing, faint echoes of propellers. The ocean covers them up again quickly, but the principle remains. Knowledge always comes with disturbance. Down here, the least disturbance is the most respectful. The best scientists learn to listen more than they act, to observe rather than impose. It's a form of humility that's rare in other fields. The ocean demands it. As the instruments descend, as cameras blink in the dark, the silence resumes its reign. The abyss doesn't resist intrusion, it simply absorbs it. Even our presence becomes another layer of sediment, another whisper in the long, slow story of this place. When the lights flicker off and the submersible rises, the water closes in behind it, seamless and calm as though nothing ever happened. That's the kind of silence the South Sandwich Trench keeps. Not the fragile stillness of a room, but the eternal kind that resets itself after every interruption. It's not waiting for us to leave. It simply continues. Far above, the world moves on, waves break on distant shores, storms gather, continents drift imperceptibly. But down here, nothing changes quickly. The trench endures in patient equilibrium, the same as it has for millions of years. That stability is deceptive, though, because beneath that calm lies motion. The tectonic plates beneath the trench are always shifting, always grinding, always pulling one another down. If we could compress geological time into a human perspective, the trench floor would look like a slow earthquake that never ends. The silence hides tension, the stillness hides force. That, in the end, is what the abyss teaches best. That quiet doesn't mean peace, it means potential. The South Sandwich Trench may seem lifeless, but it's part of the living pulse of the planet. Its silence isn't emptiness, it's the sound of creation stretched across millions of years. Every centimetre of movement, every grain of sediment that drifts down, every creature that flickers briefly through its darkness, all are part of an ongoing process of renewal and decay that never stops, only slows. The deeper you go, the more you realise that the trench isn't asleep. It's awake in a language we don't yet understand, and so we keep listening. Because somewhere in that silence, hidden among pressure and cold and time itself, there are answers waiting to surface. The South Sandwich Trench, quiet as it is, continues to whisper to the instruments we leave behind. And as those signals travel upward, across kilometres of water, through currents and noise, they bring with them fragments of the story we're only beginning to read. The descent continues, the darkness deepens, and the silence gives way to something subtler, a faint vibration that hints at movement beneath the calm. The earth is still talking, even here, and it's time to start hearing what it's saying. The deeper we go, the more the world begins to take shape again, though it's not the kind of shape the surface would recognise. Up above, landscapes are carved by wind and rain, by ice and time. Down here, it's pressure, heat and gravity that do the carving. The South Sandwich Trench doesn't look like a simple crack or valley. It's an enormous folded scar in the crust of the earth, curved like a bow stretching across the floor of the southern Atlantic. To see it mapped is to realise how vast it really is, almost 1,000 kilometres long, a sweeping arc from the northeast to the southwest, pressed against the edge of the South Sandwich Island chain. Its maximum depth, measured in 2019 by advanced sonar systems, reaches nearly 8,376 metres. That's more than 5 miles straight down, a vertical journey longer than any mountain climb on land. The shape of the trench isn't uniform. It rises and falls, broken into smaller basins and ridges, each one a story in the slow language of geology. The walls are steep, plunging in some places almost vertically before levelling out into narrow plains. Along those slopes lie sediments carried from the volcanic islands above, ashes, fragments of basalt, and fine grains of dust that drift down through the centuries. The lower you go, the more compacted those layers become until they're no longer silt but rock, pressed together by time and pressure into something close to marble. And beneath that rock lies the subducting plate, the South American slab of crust sliding under the South Sandwich Plate at a rate of roughly 70 millimetres a year. That's about as fast as your fingernails grow. It sounds insignificant until you remember that the Earth measures its patience in millions of years. At that rate, whole continents rearrange themselves. You could imagine it as a colossal conveyor belt, one plate slowly diving under another. Where they meet, the upper plate is forced upward, creating the volcanic arc of the South Sandwich Islands, while the lower one bends and disappears into the mantle. The trench marks the point of surrender, where solid rock begins its descent into heat and pressure. The geometry of that meeting is what gives the trench its distinctive curve, a graceful sweep born of collision. It's not chaos, it's choreography. Every fault, every fracture, every rise and dip is part of a balance maintained between the forces that shape the planet. Gravity pulls down, Buoyancy pushes up, and the crust, brittle but stubborn, bends in between. That bending, that quiet resistance, is the South Sandwich Trench. It's hard to visualize such a landscape. Even with sonar maps and 3D modeling, the mind struggles to grasp a world defined by negative space. The trench isn't built upward like a mountain, it's carved downward. Everything about it is subtraction. Material lost, crust consumed, matter sinking back into the planet. If you could drain the ocean and stand at the edge of it, the sight would be overwhelming. Towering walls of basalt, ridges rising like petrified waves, valleys so wide they could swallow entire cities. The light would fall strangely here, fractured by mist and mineral dust, turning even the hard edges soft. The scale would defy language. You'd feel small not because of distance, but because of depth, because space itself seems to stretch differently when it goes downward instead of out. When scientists mapped this region in detail, they found that the trench floor isn't a flat plain as once assumed. It undulates with small hills and depressions shaped by landslides, earthquakes, and the constant settling of sediments. In some places, the trench narrows into canyons only a few kilometers wide. In others, it opens into broad basins where mud has gathered undisturbed for thousands of years. These basins act like traps for organic material drifting down from above. Over time, they form deposits rich in carbon, the fossilized remains of countless plankton and microorganisms. These silent repositories play a quiet role in Earth's climate system, locking away carbon that would otherwise remain in circulation. Even here, geometry has consequence. At the trench's southern end, near 60 degrees south latitude, the floor deepens sharply into a section known as the Meteor Deep, one of the least explored points on the planet. It was named after the German research vessel Meteor that first surveyed it in the 1920s. Back then, the technology was primitive, sounding lines dropped by hand, echo pulses barely capable of reaching the bottom, but the readings they returned hinted at something extraordinary. Later expeditions confirmed it. This was the deepest point in the entire Atlantic Ocean. Today, the Meteor Deep remains a benchmark for the limits of exploration. Fewer people have seen it than have walked on the moon. No crude submersible has yet descended there. Only remote instruments have touched its surface, their light swallowed by silt and pressure before they could record more than a glimpse. One of the reasons it's so difficult to explore is the trench's shape itself. Its sides are unstable, its sediments prone to sliding. Earthquakes are frequent here, small tremors rippling through the crust as the plates adjust their grip. Each quake sends clouds of sediment billowing into the water, reducing visibility to nothing, and sometimes burying equipment left on the seafloor. To work here, machines must be both delicate and durable, light enough to float, strong enough to survive pressure, smart enough to operate blind. Even then, missions often fail. The trench seems to resist intrusion not through hostility, but through complexity. It's geometry designed by a planet, not for us. Still, when data does come back, it paints a portrait of staggering precision. The trench walls show patterns of faulting and folding that speak of ancient violence. You can trace lines where rock has sheared and shifted, where molten material once rose through cracks and solidified into veins of darker stone. In some sections, the seafloor bears long ridges of pillow lava, rounded forms that look almost soft, created when magma erupted into the cold sea water and froze instantly. These frozen eruptions tell us that even here, beneath kilometers of water, the Earth is alive with heat. The trench isn't just a grave where crust goes to die. It's also a forge where new rock is born. Near the volcanic islands, hydrothermal vents dot the seafloor, releasing plumes of mineral-rich water heated by magma below. These vents build chimneys of iron and sulfur that rise like coral reefs in miniature, though instead of sunlight, they feed on chemistry. Around them cluster communities of bacteria and small animals that rely on chemosynthesis, turning inorganic compounds into energy. It's an ecosystem without sun, proof that life doesn't need light, only opportunity. Some of these bacteria are so unique that they've become models for astrobiology, the study of how life might exist on other planets. If organisms can thrive in the crushing dark of the South Sandwich Trench, perhaps something similar could live beneath the icy crust of Europa or in the methane seas of Titan. The shape of the deep, then, isn't just Earth's secret. It might be a map to understanding life itself. Above these vent fields, the terrain changes again. The trench floor rises into low ridges where the descending plate begins to melt, generating pockets of magma that eventually feed the volcanoes on the islands above. The transition from trench to arc isn't a clean boundary, but a gradual shift from cold, dense rock to molten fluidity. You can think of it as a gradient from silence to motion, from stillness to eruption. The same forces that create the deepest quiet are responsible for the loudest explosions. It's one continuous system, both violent and serene. This geometry extends far beyond what we can see. The subducting plate doesn't stop at the trench. It plunges hundreds of kilometers into the mantle, dragging oceanic crust deep into the Earth's interior. There it melts and mixes with other material, recycling the planet's outer shell in a process that has continued for billions of years. Every mountain, every continent, every grain of sand on a beach has passed through this cycle countless times, born from volcanic rock, eroded, submerged, and drawn down again. The South Sandwich Trench is one chapter in that cycle, a temporary stage in a process so vast it makes human time feel irrelevant. To stand above it, or to float above it, is to glimpse the machinery of a living world. The data from this region also shows how interconnected the deep ocean is. Currents that pass through the trench influence circulation patterns across the South Atlantic, affecting climate thousands of kilometers away. The shape of the seafloor guides these currents like a sculpted channel, directing the flow of cold, nutrient-rich water northward. This deep current eventually surfaces in distant oceans, feeding plankton blooms that support entire ecosystems. A ripple here, invisible and slow, can echo as far away as the equator. It's a reminder that nothing in the ocean exists in isolation. Even the most remote trench participates in the choreography of global balance. When oceanographers talk about the shape of the deep, they're also talking about data. The maps we make are built from sound, sonar pulses bouncing off rock and returning as echoes. The time it takes for those echoes to come back tells us the distance, and the variations in their intensity reveal texture. Over time, millions of these measurements form a digital model of the seafloor, but even the most detailed map is still an approximation. The ocean distorts sound, bends it, delays it. Pressure and temperature change the speed at which it travels, so what we see in those images isn't the trench itself, but an interpretation of its silence. We're reading echoes and building landscapes from memory. There's something poetic in that, though not in a sentimental way. The idea that we can only understand the deepest parts of our planet through reflection, through listening rather than seeing, feels fitting. The trench refuses to show itself directly. It's not a place you can photograph easily or walk across. Its shape is known through patience, through instruments that send questions into the dark and wait for replies that take seconds to return. Each echo is a word in an ongoing conversation between humans and the Earth, one that spans distance, pressure, and time. The trench answers, but only in whispers. In recent years, high-resolution mapping has revealed features we never knew existed. Small seamounts rise from the trench floor like hidden islands, their peaks sharp and solitary. Some are remnants of extinct volcanoes carried downward by the subducting plate. Others are new formations born from magma leaks. There are fissures several kilometers long where gases escape in slow streams of bubbles. These vents may play a role in regulating the chemistry of the ocean, balancing the exchange of carbon and sulfur between the deep and the surface. The more we look, the more intricate the trench becomes. It's not a void, but a network, a landscape with structure and logic. It's tempting to think of the deep ocean as static, frozen in darkness, but the truth is that it's constantly shifting. The South Sandwich Trench moves every day, imperceptibly, as the plates beneath it continue their endless negotiation. Some areas rise by millimeters, others sink. Earthquakes relieve tension, only for it to build again. The geometry of the trench is dynamic, alive. In that sense, its shape isn't fixed. It's an evolving conversation between rock and water. What we map today may not be precisely the same tomorrow. The deep remembers every movement. For all our technology, our knowledge of this place is still fragmentary. Less than a handful of missions have gathered direct samples from the trench floor. Each brought back new surprises, unusual microbial mats, mineral deposits formed under pressure, sediments layered in ways that suggest undersea avalanches. Every discovery expands the picture, but also reveals how much remains unknown. The shape of the deep isn't just a physical structure, it's a metaphor for understanding itself. Every new contour we uncover exposes another layer we didn't know existed. And so, as we drift through this mental descent, it's worth pausing to appreciate the scale of what we're imagining. Beneath thousands of meters of cold water lies a world more complex than most mountain ranges, built from forces older than any civilization, moving at speeds too slow for the human eye to notice. It's a landscape that doesn't need light to exist. Its beauty isn't visual, it's structural. The curve of a ridge, the angle of a slope, the precision of a fault line, these are the aesthetics of geology. The trench is, in a way, the purest form of landscape, unobserved, unmodified, untouched. And somewhere within that shape there's motion we can't yet see. Tremors running through basalt, heat pulsing upward, sediment settling in invisible drifts. The deep isn't still, it's sculpting itself every second. The South Sandwich Trench, in its cold and crushing silence, continues to write the story of the planet in lines too vast for us to read all at once. What we can do is keep tracing those lines, keep listening to the echoes, and keep descending. Because below even this, the story goes deeper still, where geology gives way to something stranger, the origins of the trench itself, and the restless forces that keep it alive. If the South Sandwich Trench feels like the edge of the world, it's because, in a sense, it is. Not the end of the planet itself, but the boundary of one piece of it, a place where the crust of the earth begins to fold, buckle, and slip back into the interior. The trench wasn't carved by erosion or impact. It was born from motion, from the slow, relentless drift of continents and oceans that never stops. The story of its birth is the story of the Earth's own restlessness, a planet that is never truly still beneath its surface calm. To understand how the trench came to be, you have to picture the Earth not as a solid sphere, but as a kind of living shell. The outer layer, the crust, is thin, no thicker in proportion than the skin of an apple. Beneath it lies the mantle, a vast zone of hot plastic rock that flows slowly over millions of years. It's this slow movement that drives what we call plate tectonics. The crust is divided into about a dozen major plates, each floating on the mantle like rafts on a molten sea. They move a few centimeters a year, sometimes toward each other, sometimes apart, sometimes sliding sideways in quiet friction. It doesn't sound like much, but over geological time it shapes mountains, oceans, and continents. The South Sandwich Trench exists because two of these plates met and refused to share space. The larger one, the South American Plate, moves eastward across the Atlantic, while a smaller, denser plate, the South Sandwich Plate, rides just to its east, carrying the chain of volcanic islands that bear the same name. Where they meet, the heavier plate bends and dives beneath the lighter one. This process is called subduction. Over millions of years, as the heavier plate descends, it drags the ocean floor down with it, forming a long, deep groove in the crust. That groove is the trench, a scar etched into the seafloor by the slow, grinding surrender of one part of the planet to another. If you could watch it happen in time-lapse, sped up by millions of times, it would look like a slow-motion wave of rock collapsing into itself. The oceanic crust would buckle and crack. Magma would rise from below, feeding volcanoes along the edge of the overriding plate. Sediments would crumble from the slopes, forming thick wedges at the bottom. Everything would shift, adjust and settle again, only to shift once more. The trench isn't a static feature. It's an ongoing process. It's being born continuously, millimetre by millimetre, as long as the plates keep moving. Even now, the seafloor around it is flexing and groaning under invisible tension. It's easy to forget that the earth beneath us is alive in this way. On human timescales, it feels immovable. Mountains seem eternal, coastlines fixed, oceans timeless. But at its core, the planet is an engine running on heat. That heat comes from radioactive decay in the mantle and core, and from the leftover energy of formation when the planet first coalesced from dust and gas over 4 billion years ago. It drives convection currents in the mantle, great looping flows of rock that carry the plates along like icebergs on a slow tide. Where those currents converge, plates collide, and one is forced beneath the other. That's what happens at the South Sandwich Trench. It's one of the most active subduction zones on Earth, constantly recycling ocean crust into the planet's interior. The story of its creation began tens of millions of years ago. Back then, the Atlantic Ocean was younger, narrower, and still growing. The South American plate was drifting westward, away from Africa, while the ancient floor of the Pacific was being consumed along the western edge of the continent. But deep beneath the southern Atlantic, a new fracture began to open, a rift that would eventually form the South Sandwich Plate. As it separated, magma rose, cooling into new oceanic crust. That new crust began to move eastward, eventually colliding with the older South American crust. The impact didn't happen suddenly. It was more like two glaciers meeting, slow, steady, unstoppable. The result was a subduction zone and the beginning of the trench. At first, it would have been shallow. The bending of the plate would create only a modest depression on the ocean floor, but over millions of years, as the subducting plate sank deeper and the overriding one lifted slightly, the depression deepened. Sediments were scraped off and piled up, forming accretionary wedges that added complexity to the trench's profile. Earthquakes became frequent, small adjustments in the crust as it accommodated the stress of being bent downward. Each quake released energy that travelled through the ocean as low rumbling vibrations, many of which can still be detected today by seismographs positioned across the South Atlantic. You might wonder why the trench is so deep when the plates move so slowly. The answer lies in the density difference between the plates and the mantle. The oceanic crust of the South American plate is old and cold, meaning it's denser than the mantle beneath it. When it begins to subduct, it doesn't just sink, it pulls itself downward, dragging the rest of the plate with it in a process known as slab pull. That downward tug intensifies the curvature of the plate and deepens the trench. It's a self-reinforcing cycle. The more the plate bends, the more it sinks. The more it sinks, the deeper the trench becomes. The South Sandwich Trench, at over 8 kilometres deep, is a monument to that invisible tug of gravity and geology. Above the descending slab, the mantle melts slightly as water and minerals are released from the sinking rock. This melted material rises through the overlying crust, feeding the chain of volcanoes that make up the South Sandwich Islands. Each of those volcanoes is a vent for the energy generated by subduction, a pressure valve for the planet's interior. Some erupt beneath the sea, building seamounts that never break the surface. Others pierce through the ocean to form small islands, many of which are still active today. Mount Belinda, on Montague Island, erupted in the early 2000s, sending plumes of ash into the sky and rivers of lava down its slopes. It was a visible reminder that the trench, though hidden, is not a relic. It's a living boundary. These volcanic islands also act as markers for the subduction zone's path. They trace the arc of the trench, curving eastward in a graceful sweep that mirrors the shape of the descending plate. The alignment isn't random, it's the geometric fingerprint of the forces below. You can think of the islands as punctuation marks in the sentence the Earth is writing across the sea floor, a sentence that speaks of movement, pressure, and time. The South Sandwich Arc is relatively young in geological terms, probably less than 10 million years old, which makes it a recent addition to the planet's tectonic symphony. But in those millions of years, it has already seen more change than human civilization ever has. When researchers study the trench today, they do so with the help of seismic tomography, a technique that uses earthquake waves to image the interior of the Earth. The results show the subducting slab plunging deep into the mantle, a ribbon of cold rock sinking into the planet's heat. It's like an X-ray of motion. These images reveal that the South Sandwich Plate doesn't just stop at a few hundred kilometers, it may extend downward for more than 1,000 before finally melting into the mantle. In that melting, the cycle completes itself. The rock that once formed ocean floor becomes magma again, eventually rising somewhere else to create new crust. Nothing on Earth truly dies, it just changes form. The birth of the trench, then, is not a single event but a continuous transformation. It began with the cooling of the planet, the creation of plates, the spreading of oceans, and the collisions that followed. Each step led to the next, until the Atlantic itself became framed by deep scars like this one. The South Sandwich Trench is part of a global pattern, one of several trenches that ring the planet's oceans, forming a network geologist called the Ring of Fire. These trenches are where the Earth's energy is most focused, where earthquakes and volcanoes remind us that the crust is not permanent but temporary. They are also, paradoxically, some of the most stable features in geological time. Once formed, a trench can persist for tens of millions of years, constantly reshaped but never erased. Even now, if you could somehow pause the planet and watch it without time, you'd see the South Sandwich region in constant motion. The plate descending beneath the trench creaks like a bending beam. The rocks within it fracture, producing deep focus earthquakes hundreds of kilometers below the surface. Above, the volcanoes respond to subtle shifts in magma pressure. The ocean floor trembles slightly with each adjustment. This is how a planet breathes, not in seconds or hours, but in cycles of heat and gravity that unfold too slowly for us to feel. Every few years, satellites detect small changes in the shape of the seafloor near the trench. The vertical motion can be measured in centimeters, but it's enough to alter the topography over time. In the long view, this movement creates new depressions, new fault lines, new possibilities for collapse. The trench is always renewing itself. It's not a finished product, not a completed sculpture. It's a work in progress, carved by forces that don't stop when we stop looking. One of the most fascinating consequences of subduction is how it connects the deep ocean to the atmosphere. As the plate sinks, it carries with it water trapped in minerals and sediments. When those materials reach certain depths, the water is released, rising through the mantle and crust. Some of it escapes through volcanoes, returning to the surface as vapor. In that way, the ocean participates in a long, looping exchange with the sky. The trench is part of that cycle, a hinge between water and fire, surface and depth. It's a reminder that Earth systems are not separate but intertwined in ways we're only beginning to quantify. From a human perspective, this all happens at an impossible scale. We measure progress in days, years, decades. The trench measures in millions of years. When we look at it now, we're seeing just one frame in a film that's been running since long before humans evolved. The islands above it will one day erode. The trench will migrate. The ocean will shift. But in our small window of observation, it feels eternal. It feels like a wound that will never close, when in reality it's healing itself slowly, endlessly, through motion. The way the trench interacts with the rest of the planet is also instructive. Every major subduction zone plays a role in shaping global seismic behavior. When pressure builds along one fault, it can relieve stress in another. The South Sandwich Trench occasionally releases that pressure through earthquakes, some of which are strong enough to be recorded across the Atlantic. Most of them happen quietly, deep below the surface, too far down to cause tsunamis or be felt by humans. But they are constant, a steady reminder that the Earth is in conversation with itself, shifting and realigning. The trench is one of the voices in that dialogue, speaking in low rumbles that only instruments can hear. For geologists, understanding the trench isn't just about knowing where it is or how deep it goes. It's about understanding the principles that make the planet dynamic. Without subduction zones like this, Earth would be a very different place. There would be no mountains, no continents, no recycling of carbon or minerals. The atmosphere would stagnate, the climate would drift toward extremes, and the surface would eventually harden into stasis. Subduction is what keeps the world alive, and the South Sandwich Trench is one of its most remote, efficient examples. In its darkness and pressure, the planet maintains its balance. There's something almost comforting about that. To know that beneath the chaos of weather, the churn of ecosystems and the noise of human activity, the Earth itself is quietly maintaining order on a scale we can barely comprehend. The trench doesn't need to be seen to matter. It doesn't need witnesses. Its work continues in the dark, steady and precise, driven by laws older than life. It is the Earth doing what it has always done, turning itself over, folding, mending, beginning again. And somewhere in that process, in the collision of plates and the rise of magma, in the slow descent of rock into the mantle, lies the explanation for why the trench looks the way it does. Its birth was not violent in the way we imagine explosions or earthquakes. It was slow, inevitable, shaped by gravity and density and the quiet certainty of physics. Every curve, every slope, every hidden ridge is a record of that birth, frozen mid-motion. The South Sandwich Trench was born from movement, and in movement it continues to live. The water above it remains still, the silence persists. But beneath that silence, the crust keeps sliding, the mantle keeps rising, and the planet keeps remaking itself. The trench isn't just a feature of the ocean floor. It's a reminder that even the most silent places are in motion, that creation can happen without sound, and that sometimes the most dramatic events unfold too slowly for us to notice at all. The deep story of how the trench was born continues even now, reshaping itself grain by grain. And somewhere in that living geology, in the endless press of water and stone, there is more to discover. Traces of the explorers who have tried to map it, and the stories of how we came to know such a forbidden place existed at all. For most of human history, the South Sandwich Trench wasn't even a name, just a blank on a map. The oceans were drawn in shades of blue that deepened toward nothing, the uncharted parts marked only with the vague label "soundings not taken." The southern Atlantic, where cold and isolation meet, was especially resistant to exploration. It wasn't that people weren't curious, it was that curiosity had limits when the world itself resisted being reached. To reach this trench meant travelling through the most remote waters on Earth, past storms that could tear ships apart, past icebergs that drifted like mountains through fog. Few went that far south without a reason, and even fewer came back with stories that anyone wanted to believe. The first to hint at its existence weren't explorers in the romantic sense, but navigators and whalers, men who mapped the southern seas out of necessity. They reported strange depths in their soundings east of the South Sandwich Islands, lead lines that kept sinking without touching bottom. Some dismissed it as error, others as equipment failure. At that time, the idea that the ocean could be deeper than any mountain was tall seemed absurd. But the anomalies persisted, small glimpses of truth buried in the routine of navigation logs. The deep was already whispering. It would just take time for someone to listen properly. By the early 20th century, oceanography was beginning to take shape as a science. Expeditions like the British Challenger in the 1870s had already revealed that the ocean was not a uniform basin, but a world of mountains, valleys and trenches. Sounding techniques improved. Ships began to carry echo sounders, devices that sent pulses of sound downward and measured their return. The Meteor expedition in the 1920s was among the first to use this technology systematically, crisscrossing the South Atlantic with sonar lines and recording the contours of the seafloor. When the ship reached the remote waters near the South Sandwich Islands, it detected something extraordinary, depths that exceeded any previously known in the Atlantic. They named it the Meteor Deep after their vessel and marked the spot on their charts. But the data was still rough, the instruments primitive, and the region so difficult to reach that no one returned for decades to confirm it. That's the nature of the South Sandwich Trench. It keeps its secrets not through deception but through distance. Every expedition here is an act of endurance. The nearest ports are thousands of kilometres away. The weather can shift from calm to chaos in an hour. Ice forms quickly on deck, and waves break high enough to smash antennas and tear away instruments. Ships that operate in these waters must be built like fortresses, and crews must accept that the ocean has the final word in every decision. Even with modern technology, reaching the trench is an exercise in humility. For much of the year, sea ice and storms make access impossible. Researchers wait for small windows of calm, weeks at most, when they can deploy their instruments before being driven north again. In the decades after the Meteor voyage, the trench became a legend among oceanographers. It was known, mapped in faint lines, but rarely mentioned. Most attention went to the Pacific, where the Mariana and Tonga trenches offered greater depths and easier access from large research centres. The Atlantic, despite being one of the most studied oceans on the planet, remained poorly understood in its southern extremes. The South Sandwich region seemed almost to repel exploration. Ships that ventured there reported constant fog, unreliable compasses, and strange interference in their instruments. Some of that was magnetic. Volcanic rock can distort compass readings, but some of it was psychological. The isolation itself played tricks on the mind. In a world of satellites and coordinates, there are still places that feel beyond orientation. The first detailed study of the trench after the meteor came in the late 20th century, when unmanned probes and deep-sea sensors made it possible to collect data remotely. In the 1990s and early 2000s, a series of research programs began mapping the South Atlantic seafloor using multi-beam sonar. These instruments could cover broad areas with each pass, producing images of astonishing clarity. It was during these surveys that the true scale of the South Sandwich Trench became clear. The deepest point, at more than 8,000 metres, lay east of the islands in a narrow valley shaped like a crescent. The surrounding seafloor rose in steep ridges, and along those ridges scientists found evidence of frequent landslides and volcanic deposits. The trench wasn't a simple groove. It was a complex shifting system, alive with geological activity. The first direct descent into this region didn't happen until the 21st century. Crude submersibles had reached the Mariana decades earlier, but the logistics of operating in the far South Atlantic were daunting. The nearest bases for resupply were thousands of kilometres away, and the unpredictable weather made launch and recovery risky. Instead, researchers turned to robotic vehicles, autonomous or remotely operated systems designed to withstand extreme depth. These machines became the explorers of the new age, venturing into places humans could not go. They were small, efficient and tireless, capable of operating for days in darkness without rest or fear. In 2019, an expedition known as the 5 Deeps Project set out to reach the deepest points in each of the world's oceans. It was led by Victor Vescovo, an American explorer and retired naval officer who had already descended to the Mariana Trench. His team included engineers, pilots and scientists from multiple nations, operating the specially designed submersible DSV limiting factor. Unlike earlier craft, this one was built for repeat dives, capable of descending to full ocean depth multiple times. The South Sandwich Trench was one of its destinations, the final frontier of the Atlantic. Reaching it required a journey of thousands of kilometers across the open ocean through some of the roughest waters on Earth. The expedition ship, Pressure Drop, battled waves and wind for days before arriving at the coordinates. The weather never fully cooperated, but there was a small break just long enough for the dive to proceed. The submersible slipped into the grey sea, its hull gleaming with condensation, and began its descent. Communication with the surface grew patchy as it dropped below the thermocline, then faded entirely. For hours, the crew on the ship waited, staring at monitors that showed only static. It was a familiar tension in deep-sea exploration, the knowledge that once a submersible descends, it is completely on its own. When the limiting factor reached the bottom, more than 8 kilometers down, the world outside its portholes was black and still. The lights illuminated a landscape of fine sediment, scattered rocks, and small, pale creatures drifting through the beam. It wasn't a dramatic view, but it was historic. For the first time, humans had reached the deepest point in the Atlantic Ocean, confirming the depth of the meteor deep and collecting samples that would help define the trench's unique ecosystem. Cameras recorded slow movements, amphipods scurrying along the bottom, translucent and ghost-like. The vehicle's robotic arms gathered sediment cores and small rock fragments. Every motion was deliberate. At that depth, even the smallest adjustment requires calculation. The dive lasted several hours before the ascent began, a long, silent climb back toward the surface and daylight. When the submersible emerged, battered but intact, the crew celebrated quietly. There were no grand speeches, no dramatic declarations, just relief, and the calm understanding that something significant had happened. The Atlantic, a place so familiar from above, had finally been explored in its deepest shadow. The samples brought back were modest in appearance but rich in data. Within those grains of sediment were microorganisms adapted to the crushing pressure, their enzymes functioning in conditions that would destroy normal cells. Studying them could lead to new insights into biochemistry, even potential applications in medicine and industry. It was a reminder that exploration doesn't always yield treasures you can see. Sometimes the most valuable discoveries are microscopic. The 5 Deeps expedition also revealed something else. The trench was even deeper than previous estimates. Using advanced sonar and pressure sensors, the team measured a depth of 8,376 meters at the meteor deep. It confirmed the South Sandwich Trench as the deepest point in the entire Atlantic, surpassing earlier data by dozens of meters. The precision mattered not only for maps but for science. Depth affects temperature, chemistry, and pressure, all variables that shape life and geology. Knowing the exact profile of the trench allows researchers to model how water circulates through it, how carbon is stored, and how seismic activity propagates. Every meter matters when you're studying the planet's least accessible systems. After the 5 Deeps mission, the South Sandwich Trench returned to its quiet. Few ships visit it, and even fewer will again soon. That's part of the rhythm of exploration here. A brief flurry of activity followed by years of absence. The data continues to be analysed long after the expedition's end, the samples catalogued, the videos reviewed frame by frame. Each image from the deep is studied for movement, for glints of life, for anomalies that might hint at something unseen. It's slow work, but then everything about this place demands patience. The trench doesn't reveal itself easily. It gives back only what's asked carefully. There's also something symbolic in how these expeditions unfold. The submersibles, the sensors, the scientists hunched over their data. They're part of a lineage that stretches back to the earliest seafarers who looked at the horizon and wondered what lay beyond it. The technology has changed, but the impulse hasn't. The South Sandwich Trench sits at the far end of that impulse, a place reached not by accident but by persistence. It's a destination that doesn't reward conquest, only understanding. One of the more surprising aspects of these missions is how quiet they are. The descent of a modern submersible isn't accompanied by drama. There's no roaring engine, no bright flare of entry. The craft sinks slowly, almost gracefully, surrounded by darkness. Inside, the only sounds are the soft hum of pumps and the occasional creak of metal adjusting to pressure. The view through the window changes slowly, from light to shadow to complete black. Outside, particles drift like dust in a beam of light, except the beam is artificial and the dust is life. The experience is less like adventure and more like meditation, a suspension of everything human in the presence of something beyond scale. Not every expedition succeeds. Some vehicles are lost, crushed by pressure or swallowed by landslides. Instruments sometimes fail before reaching the bottom. Weather can force ships to abandon their plans entirely. The ocean doesn't care about schedules or funding cycles, it allows what it allows. That's part of the reason the South Sandwich Trench remains so mysterious. It's not defiance, it's indifference. The abyss doesn't hide from us, it simply doesn't notice we're looking. Over time, as data accumulates, a pattern emerges. The expeditions that succeed share a certain humility. They approach the deep not as conquerors but as listeners. They design instruments to be quiet, to minimize disturbance. They accept that visibility will be poor, that the current may shift, that the terrain might change between visits. They know that the deep ocean is not static, and that what they record today might be gone tomorrow, buried under new sediment or reshaped by an undersea quake. Exploration here is less about mapping territory and more about forming a relationship with an environment that will never fully belong to us. Every sample collected, every sonar image, every recorded sound contributes to a larger picture of what the South Sandwich Trench truly is. Not an abyss of emptiness, but a dynamic system where geology, chemistry and biology meet in quiet equilibrium. The expeditions in shadow are slow, patient acts of connection. They extend human presence into a place where human life cannot persist, not to claim it, but to understand it just a little better. And the story isn't finished. New missions are planned, each building on the last. Autonomous underwater vehicles are becoming more capable, able to map larger areas with greater precision. Advances in communication may one day allow live transmission from the depths, though for now the delay between question and answer remains long. The ocean still dictates the pace. The trench will likely be revisited, measured again, photographed again, its silence translated into data and meaning, and then it will fall quiet once more, holding its shape and secrets until someone else decides to listen. The legacy of these expeditions isn't only scientific, it's philosophical. They remind us that exploration isn't about reaching a finish line, it's about continuing to ask questions in the face of endless depth. The South Sandwich Trench doesn't offer closure or discovery in the cinematic sense. It offers perspective, a reminder of how small we are, how much we still don't know, and how that ignorance is not a flaw but a kind of grace. The deeper we go, the more the world opens. Somewhere down there, in that crushing black stillness, instruments still sit quietly, recording temperature, pressure, and the faint vibrations of the earth. They send their signals upward through kilometers of cold water, data packages travelling slowly towards satellites that will relay them to the surface world. Those signals are the modern equivalent of the explorers' voices, calling back from the unknown, and just as before, we listen, not always understanding, but always curious. The expeditions in shadow continue quietly, persistently, and while the trench remains unseen by most, its story deepens with every descent, because somewhere beneath the waves, where darkness outweighs light, the planet is still writing, and we are still learning how to read. When people imagine the deepest parts of the ocean, they often picture emptiness, a cold, silent desert where life has been pushed out by darkness and pressure. It seems logical that nothing could live where water weighs hundreds of times more than air, where temperatures hover just above freezing, and where the only light is the faint glow of distant volcanoes or the weak reflection from a submersible's lamp. But the South Sandwich Trench, like every part of the planet that we once assumed to be lifeless, refuses that assumption. Life persists even here, adapted beyond what our imaginations would think possible. It doesn't just survive the crushing depth, it belongs to it. When the first probes descended into the trench, scientists expected little more than mud and rock. Instead, the cameras revealed motion. Small translucent forms drifting in the beams of light, some darting away, some hovering calmly, others pulsing with slow rhythm as if the water itself were breathing through them. It's difficult to describe what these creatures look like because nothing on land quite compares. The absence of sunlight has stripped away colour, leaving bodies clear or milky white. Eyes, where they exist, are simple and small. Muscles are soft, bones minimal. Every feature has been refined to cope with pressure and scarcity. There's no wasted energy in the abyss. Everything has a purpose, and every purpose is survival. At the upper slopes of the trench, where the pressure is merely immense instead of impossible, live some of the most studied inhabitants, amphipods. They're small crustaceans, no bigger than a fingernail, but in the deep they're the equivalent of grazers on a vast invisible plain. Their bodies are soft, flexible, and nearly transparent. Their shells, which on the surface would be rigid, are thin and pliable here, laced with chemicals that prevent collapse. Inside their cells are special molecules called piezolites, natural stabilizers that stop proteins from breaking down under pressure. These same compounds, when studied in laboratories, may hold clues for biotechnology, helping us understand how to design materials and enzymes that function under extreme conditions. The amphipods don't know this, of course. They just drift through the dark, feeding on the fine dust of organic matter that rains from above. To them, every flake of decaying plankton or fragment of fish is a meal. In a world where food arrives like snow, patience is a survival strategy. The deeper the descent, the stranger the inhabitants become. Snailfish, for example, are among the highest known vertebrates in the trench. They resemble pale ribbons with faint fins and a slow undulating motion. Their bodies are more gelatin than muscle, perfectly suited to withstand pressure that would crush bone. They have no scales, no swim bladders, and little need for speed. Instead, they conserve energy, drifting with the current, sensing vibrations through the water rather than relying on sight. When a camera captures one, it looks like a ghost hovering in slow motion, unbothered by the mechanical lights that momentarily intrude upon its world. These fish are fragile, yet they thrive where nothing else does. Their cells are filled with compounds that act like antifreeze, preventing ice crystals from forming even at temperatures near zero. They live long, uneventful lives, each one a quiet testament to adaptation's patience. The trench floor, though mostly still, isn't barren. The sediments are alive with microorganisms, bacteria and archaea that feed on chemical gradients rather than sunlight. Some use traces of methane or hydrogen sulfide released from the rocks. Others break down organic matter that has drifted down from the upper ocean. In doing so, they create a delicate web of life that sustains larger creatures. The deep-sea ecosystem is built on recycling. Nothing is wasted. A single dead fish can nourish an entire community for months. The microbes decompose its flesh, amphipods pick apart what remains, and smaller worms burrow through the sediment to absorb the final residues. It's a slow, efficient cycle, elegant in its simplicity. Where we see death, the abyss sees continuity. One of the most fascinating discoveries in the South Sandwich Trench came from samples collected by the Five Deeps expedition. When scientists examined the amphipods brought back from the depths, they found something unexpected inside their bodies: tiny fragments of plastic. Microplastics, likely carried from the surface by sinking debris, had become part of the diet of creatures that live 8 kilometers below sea level. It was a sobering finding. The isolation of the trench had not protected it from the reach of human activity. Even here, In the darkest corner of the Atlantic, traces of the modern world had arrived. Yet in a strange way, the amphipods had adapted even to this. The plastic fragments had been partially coated with biofilms, thin layers of bacteria and organic matter that made them easier to digest. The creatures were doing what life always does, taking what exists and making it part of their survival. Still, most of the trench remains beyond what our cameras have captured. The total biomass down there is small, spread thin across vast distances. There are no large predators, no schools of fish. The energy available simply doesn't allow it. Every organism is part of a delicate economy of scarcity. Movement is measured in centimetres, feeding in hours. Reproduction happens slowly, with long pauses between generations. Some species likely go decades without major change. The rhythm of life here is geological rather than biological. It mirrors the trench itself, slow, patient, deliberate. Occasionally, larger carcasses sink from the surface, creating what biologists call food falls. A dead whale, for instance, might drift down over the course of weeks, finally coming to rest on the seafloor like a fallen moon. When that happens, the ecosystem briefly flares with activity. Amphipods swarm the carcass, followed by scavenging fish and bacteria. The decomposition releases nutrients that feed the surrounding sediments, creating a localized bloom of life in an otherwise quiet landscape. Over months, the whale's bones are stripped clean, colonized by specialized worms and microbes that feed on lipids within the bone itself. Even after the visible remains are gone, the chemical traces linger, sustaining microbial life for years. These events are rare, but they're crucial. In the deep, a single meal can shape an ecosystem's history. The absence of sunlight also means that life here has evolved sensory systems we barely understand. Many deep-sea organisms rely on touch, vibration, and chemical signals instead of sight. Some can detect pressure changes so subtle they could feel a passing current meters away. Others emit faint light of their own. Bioluminescence used not for hunting or display but for communication or camouflage. A flash of blue-green light can mimic the shimmer of falling debris, confusing predators. Some species produce constant low-level glows like faint lanterns drifting through the dark. In the South Sandwich Trench, where the water is often filled with particles, even these glows fade quickly. But they're there, hidden in the shadows, tiny conversations in a language of light and silence. What makes these creatures particularly fascinating isn't just their appearance or their chemistry, it's their resilience. Pressure at the trench's deepest point exceeds 800 times the atmospheric pressure at sea level. To put that in perspective, it's like balancing a stack of 50 jumbo jets on your body. Yet life has found ways to thrive there, not by resisting pressure, but by incorporating it. Proteins that would normally unfold or collapse at that level are stabilized by small molecular adjustments. Cell membranes are made from flexible lipids that remain fluid under compression. Enzymes have evolved to function in cold, oxygen-poor environments. Each adaptation is a quiet engineering marvel, honed by millions of years of evolution without witness or applause. Some researchers suspect that the genetic mechanisms underlying these adaptations could be among the oldest on Earth. The deep ocean has changed little over geological time. It's been cold, dark, and pressurized for hundreds of millions of years. That means the creatures that inhabit it may carry ancient traits, evolutionary holdovers from the earliest life forms. Studying them could help us understand not just how life persists under pressure, but how it began in the first place. The conditions of the deep resemble those of the early Earth. No sunlight, high pressure, rich in minerals and chemical gradients. It's possible that life itself first appeared in such environments, in vents and trenches where energy flowed from the planet's interior rather than the sun. The South Sandwich Trench in that sense is both a descendant and a reminder of those origins. When biologists retrieve samples from such depths, the challenge isn't just finding them, it's keeping them alive. The pressure difference between the trench and the surface is so extreme, that most deep-sea organisms die long before reaching daylight. Their cells expand, their structures rupture, their chemistry fails. To study them intact, scientists use special pressurized chambers that simulate the deep environment. It's a delicate process, and even with care, many specimens can only be observed briefly. But in those fleeting moments, we learn something profound about adaptability. Life can occupy almost any space the planet provides. There are bacteria living in boiling vents, in acid pools, in frozen glaciers, and here, crushed under kilometers of water. The limits of life are not where we thought they were. The more we study these creatures, the clearer it becomes that the deep sea is not an isolated anomaly. It's an integral part of Earth's biosphere. The organisms that live here play a role in carbon cycling, nutrient distribution, and even climate regulation. When they feed, die, and decompose, they help sequester carbon in the sediments, effectively trapping it away from the atmosphere for centuries. They are quite literally maintaining the planet's balance. Without them, the ocean would function differently, less efficiently, less stable. Every amphipod, every microbe, every unseen organism contributes to that global system. The abyss isn't just a curiosity, it's a foundation. Despite all our advances, we've likely seen only a fraction of the life that exists in the South Sandwich Trench. Remote cameras capture movement that defies classification, shapes that drift past the lens and vanish before a clear image forms. Some may be known species distorted by perspective, others completely new. The challenge is that each observation is rare, each encounter fleeting. The pressure and darkness make extended observation nearly impossible. But what glimpses we have are enough to remind us that discovery doesn't end with mapping or measurement. There are still entire forms of life waiting in the dark, unnoticed and unnamed. Somewhere near the trench walls, microbial mats cling to rocks, feeding on minerals leaching from volcanic vents. Tiny worms crawl among them, blind and colourless. In the soft sediment below, bioturbation, tiny burrowing movements, continues endlessly, slowly mixing the top layers of the seabed. This quiet motion aerates the mud, distributing nutrients, shaping chemistry. Every inch of the trench floor, though it looks still, is in fact alive with subtle motion. It's not the kind of life that draws attention, but it's persistent and necessary. The more we look, the more we realize that the deep ocean isn't separate from the rest of the world. It's the foundation that everything else depends on. What's remarkable is that many of these creatures live longer than their shallow water relatives. The cold slows metabolism, the pressure reduces energy demand, and the scarcity of food discourages haste. Some amphipods may live for decades. Certain deep-sea fish reach maturity only after many years, reproducing rarely but with high survival rates for their offspring. It's an existence defined by patience. There's no competition for speed, no race for growth. Time itself moves differently here. The creatures of the trench have synchronized with the planet's slowest rhythms, and in doing so, they've achieved a kind of equilibrium that surface life can't imagine. When scientists speak about these organisms, there's often a tone of quiet awe. It's not just admiration for their biology, but for what they represent. A form of life utterly free from our influence until recently. They've evolved without light, without seasons, without any of the cues that shape life on land. Their world is constant, predictable in its stillness, a laboratory of stability. And yet, that stability is fragile. Even small changes in temperature or chemical composition could ripple through the system. Climate change, for example, is altering deep water circulation patterns, potentially changing how nutrients and oxygen reach the trench. The creatures below have no defense against such shifts. They've never needed one. For millions of years, their world has remained the same. Only now is it beginning to change. There's a strange intimacy in knowing that. The amphipods feeding in darkness, the snailfish hovering like silk in the water, the microbes weaving invisible webs through the mud. They're part of our planet's story, even if they never know us. Their existence adds weight to the idea that life will find a way in any condition, as long as the laws of physics allow it. They remind us that adaptation isn't always about strength or dominance. Sometimes it's about yielding completely, about becoming so perfectly attuned to your environment that resistance disappears. The creatures of the trench don't fight pressure, they embody it. They don't seek light, they exist without needing it. In that sense, they're the purest form of survival we know. The trench remains dark, silent, and alive. Every descent brings back new footage, new data, new questions. We learn that the ocean isn't a single ecosystem, but a continuum of layers, each one shaped by different balances of light, temperature, and pressure. The South Sandwich Trench is simply the deepest, the final link in that chain. It's a reminder that life doesn't end where light does. It just changes shape, softens its edges, slows its pace, and keeps breathing in ways we're only beginning to understand. And somewhere below the next layer of sediment, beneath the soft shifting of mud and the slow drift of water, there are more secrets waiting. Fossilized shells, dormant microbes, chemical signatures from ancient eruptions, all records of a living planet written in pressure and silence. To know the trench's creatures is to glimpse not just biology but continuity itself, the unbroken thread of life that has stretched from the first cell to this moment, surviving every shift and silence in between. The descent continues, deeper still, where the silence grows heavier and the forces shaping this world become even more powerful. Beyond the living creatures lies the physics of their endurance, the weight, the darkness, and the unseen equations that define existence here. That's where we go next, into the quiet mechanics of survival, into the science of pressure and silence. Pressure is the language of the deep. It's what defines every movement, every sound, every living thing below a few hundred meters. The further you descend, the more it becomes the single constant that shapes existence. It doesn't announce itself with violence or sudden force. It builds slowly, one atmosphere at a time, each layer of water stacking upon the next until, at the bottom of the South Sandwich Trench, the weight equals that of nearly 800 elephants balanced on a single square metre. It's not an abstract number, it's the feel of the world pressing inward from every direction, relentless, absolute, and yet, somehow, perfectly stable. To imagine that pressure is to understand something fundamental about the ocean. Water is heavy, but it's also incompressible. As it deepens, it transmits the full weight of everything above it without pause. At the surface, we live under one atmosphere of pressure, about 14.7 pounds per square inch. By 100 meters, it doubles. By 1,000, it's nearly 100 times what your body experiences right now. At the depth of the South Sandwich Trench, over 8,000 meters down, the pressure reaches about 100 times that of the surface. Every square inch of a submersible's hull endures more than a ton of force. If even a small weakness appears, a flaw in metal, a bubble in the composite, it's enough to trigger collapse. The ocean doesn't yield, it corrects instantly. That kind of environment forces both machines and life to adapt in ways that seem impossible. A submersible like the ones that explore these depths must be built like a paradox, strong enough to resist pressure, yet light enough to sink. Engineers use titanium spheres for crew compartments, since a sphere distributes pressure evenly. Every bolt, every weld, every sensor must be tested for tolerance. Even then, when the craft descends, it creaks and groans, not out of failure but in conversation with the water. Metal contracts under stress. Circuits behave differently. Lights dim slightly as resistance changes. Everything inside those few centimeters of hull is in negotiation with the ocean outside. The deeper it goes, the quieter the machine becomes, as if the pressure itself is absorbing sound. For living organisms, resistance isn't an option. They can't reinforce themselves with metal or adjust their trajectory by design. They must evolve in partnership with pressure, That's why so many deep-sea creatures are soft-bodied. Bone, shell, and air are liabilities at this depth. Rigid structures create weak points where pressure can concentrate and cause collapse. So evolution took a different path, flexibility instead of strength. The bodies of snailfish, amphipods, and jelly-like plankton are composed mostly of water, which equalizes internal and external pressure. There's no battle between inside and out because the difference is almost non-existent. In a sense, the creatures of the trench have surrendered to pressure completely, and that surrender is what allows them to survive. Inside their cells, the chemistry tells the same story. At surface level, proteins and enzymes fold into precise shapes that allow them to function. Under high pressure, those shapes would normally collapse, disabling essential processes. But in the deep, evolution has introduced tiny molecular adjustments. Certain compounds, piezolites for example, bind to proteins and keep them from unfolding. Membranes that would stiffen at low temperature are built from unsaturated fats that remain fluid. Every microscopic part of the organism participates in balancing internal order against external force. It's a perfect equilibrium, one that has taken millions of years to achieve and could be disrupted by even small environmental changes. The deep isn't forgiving, but it's consistent. That consistency is what life has learned to depend on. Pressure also alters how energy moves. Sound, for instance, behaves differently in the deep ocean than it does in air. On land, sound dissipates quickly. In water, it travels farther and faster, but at extreme depth, where the water is cold and dense, its path bends and slows. It can become trapped in layers, refracted between temperature gradients. This creates what oceanographers call the deep sound channel, a layer in the ocean where sound can travel thousands of kilometers with little loss. In the South Sandwich Trench, far below that channel, sound behaves more unpredictably. It can scatter off the rough walls, weaken in turbulence, or be absorbed entirely by soft sediments. The result is an acoustic stillness that seems unnatural to human ears. If you could somehow be there without being crushed, you'd hear almost nothing. Even the crackle of geological movement would be muffled to near silence. That silence isn't emptiness, though. It's information hidden in stillness. The absence of constant sound means that when something does happen, a rock slide, a small quake, a movement of water, it carries meaning. Researchers use hydrophones to record these faint noises, translating them into signals that can reveal geological activity. The recordings from the South Sandwich Trench often show long stretches of quiet broken by single deep tones that last a few seconds. Some correspond to distant earthquakes, others to the carving of icebergs from Antarctica. The ocean transmits these events like a whisper travelling through walls. The trench acts as a resonator, amplifying certain frequencies while muting others. Each echo tells a story of energy moving through the planet. At such depths, even temperature behaves differently. Near the surface, sunlight warms the water, and currents mix it constantly. But below a few hundred meters, that mixing slows. By the time you reach the abyssal zone, the temperature has stabilized at around 2 degrees Celsius, and by the Hadal depths of the trench, it drops even lower, to nearly freezing. The cold combines with pressure to slow chemical reactions dramatically. Metabolism, decay, and diffusion all proceed at a fraction of their surface rates. This slowdown is part of why the deep sea feels timeless. Processes that take hours in shallower water can take years here. The very chemistry of life is stretched thin by cold and weight, until it resembles something outside of time. The silence, too, extends beyond sound. It's the absence of visual chaos, of movement, of anything that changes quickly. Light cannot penetrate more than a few hundred meters into the ocean, and at the trench's depths, the only illumination comes from artificial sources or bioluminescence. Even those are weak and fleeting. A submersible's lights reveal particles suspended in water, but as soon as the beam passes, they vanish again. For the creatures that live there, sight is irrelevant. Their sensory world is tactile and chemical, not visual. To exist in that darkness is to exist in a kind of pure awareness, where survival depends on the faintest cues, a shift in current, a trace of scent, a vibration too small for us to perceive. The silence is not emptiness. It's full of signals that we simply don't have the instruments to detect. In many ways, the trench operates as a natural laboratory for studying pressure itself. Scientists place sensors along its slopes to measure strain in the crust. These instruments can detect movements smaller than a millimetre, translating the slow bending of the earth into data. The results show that the trench isn't static. It flexes rhythmically, responding to tides, earthquakes, and even the weight of passing storms above. When atmospheric pressure changes over the ocean surface, that change travels downward as a faint pulse, measurable even in the deepest regions. The connection between sky and abyss is literal, a reminder that no layer of the planet exists in isolation. The science of pressure also extends to materials. The alloys used for deep-sea exploration are tested against compression that would destroy anything not perfectly engineered. Titanium, glass, ceramics, all must perform flawlessly. A single bubble in a glass sphere can become a fatal weakness under stress. Engineers speak of implosion depth, the point at which material integrity fails catastrophically. When it happens, the collapse is instantaneous, violent beyond comprehension. The pressure difference is so great that the surrounding water rushes in faster than the speed of sound, obliterating everything inside before a human could register the event. It's not drama, just physics. The ocean enforces precision without mercy, but beyond the mechanics, pressure has psychological and philosophical resonance. When explorers describe their time in submersibles, they often mention a peculiar calm. Knowing that so much weight surrounds them should inspire fear, yet it produces the opposite. The pressure, though immense, is invisible and uniform. There's no motion, no turbulence. The craft floats perfectly still. The silence and weight combine to create a kind of suspended existence, a moment where thought slows to match the environment. It's as if the mind, like the body, adjusts to the rhythm of the deep. The sense of time stretches. Minutes become longer, conversation softer. Even inside a machine built by humans, the atmosphere of the trench asserts itself. What makes pressure so fascinating is that it's both destructive and essential. Without it, the ocean wouldn't behave as it does. Pressure drives circulation, influences chemistry, and shapes the geology of the seafloor. It's what causes cold water to sink and warm water to rise, establishing the global conveyor belt of currents that regulate climate. It governs the solubility of gases, the formation of minerals, and the movement of tectonic plates. In short, pressure is one of the main forces that keep the planet functioning. The South Sandwich Trench simply represents its most concentrated expression. Silence, in turn, is the byproduct of that environment. It's not quiet in the sense of absence, but in the sense of balance. Every force has found its counterpart. Motion meets resistance, energy meets absorption. The result is a steady equilibrium where sound has no need to exist. On the surface, noise is constant because the atmosphere is unstable. Winds, temperature shifts, human activity. But in the deep, nothing competes for space. The silence is absolute because everything is already in place. It's not the stillness of death, but of completion. For the creatures that live there, that silence is home. Studying this interplay between pressure and silence has practical applications too. It helps scientists understand how sound travels in the ocean, which affects everything from submarine communication to the migration of whales. It informs climate models, since the movement of deep water influences how heat and carbon are distributed globally. It even shapes our approach to engineering materials for other worlds. The conditions of the trench are similar to those on the icy moons of Jupiter and Saturn, where oceans may exist beneath layers of ice. Understanding how pressure shapes water and life here gives us a framework for imagining what might exist elsewhere. Yet for all its usefulness, the experience of the deep remains profoundly human. There's something about pressure and silence that speaks directly to our perception of existence. We're used to living in noise and motion. To encounter an environment where neither exists is to confront the limits of what feels normal. The trench teaches that equilibrium doesn't require light or air or movement. It can exist in darkness and weight. The creatures that live there embody that lesson completely. They're not fighting their environment, they are its expression. The data gathered from the South Sandwich Trench continues to refine our understanding of how pressure influences everything from sound propagation to microbial life. Instruments measure the compressibility of water, the solubility of gases, the deformation of rock. Every number adds another layer to our map of how the planet behaves under stress. What emerges is not a portrait of chaos, but of precision. The deep ocean is consistent, predictable in its extremes. It is, in a way, the Earth's most perfect system. Even so, the silence there remains beyond full comprehension. When hydrophones record it, the playback on the surface often sounds like nothing, just a flat line, a faint hiss. But beneath that simplicity lies complexity we can't yet pass. Perhaps the trench's silence isn't silence at all, but a form of communication too subtle for our instruments. The vibrations of moving plates, the pulse of the Earth's rotation, the minute oscillations of tides, all combine into a rhythm that exists beyond human hearing. The ocean, in its depth, may be speaking constantly in frequencies we simply haven't learned to translate. The South Sandwich Trench, more than almost any place on Earth, illustrates that paradox. It's a realm of extremes that somehow feels calm. The crushing weight doesn't create destruction but balance. The silence doesn't erase life but preserves it. To study it is to recognize how pressure and stillness can coexist, not as opposites, but as partners. The trench is not a place where life ends, but where the fundamental laws of physics and biology meet in perfect negotiation. And within that negotiation, everything endures. If we listen long enough, through the instruments that translate vibrations into sound, we might begin to hear faint patterns. They won't be melodies or voices, just slow variations in frequency and amplitude. But to those who know how to read them, they speak volumes about the planet's interior. They tell of magma rising, of plates shifting, of energy released and absorbed. The silence of the trench is a book written in pressure waves, and every page is still being read. And beyond the instruments, beyond the human attempts to quantify and interpret, the trench continues unchanged. The water presses inward, the rocks flex, the creatures drift, the weight remains absolute, the silence unbroken. It's the most consistent environment we know, a reminder that stability doesn't require light or sound or motion. It requires balance. The science of pressure and silence is ultimately the science of balance itself, the way the universe holds itself together layer by layer until even the heaviest forces become quiet. Somewhere within that equilibrium, energy begins to stir again. The same tectonic forces that created the trench continue to reshape it. Heat seeps upward from the mantle, finding cracks, rising as plumes, feeding volcanoes hidden in the cold. The silence gives way to tremors, the stillness to slow fire. The next layer of the story lies there, in the meeting of ice and magma, in the paradox of volcanoes that bloom beneath the coldest sea. Isolation in the deep ocean isn't an emotional condition, it's a physical fact. Down in the South Sandwich Trench, separation is absolute. Light can't reach it. Sound from the surface fades long before it arrives. The nearest continent lies thousands of kilometers away. The nearest ship routes hundreds. Even the currents that travel through this part of the Atlantic are cold, slow, and self-contained. More like rivers of density than streams of movement. Everything here is cut off, not by distance alone, but by layers of pressure, darkness, and time. It's a place where the planet withdraws from itself, where silence and separation become the default state of being. The isolation begins long before reaching the bottom. As a vessel descends, the familiar cues of the world disappear one by one. The blue of the sea fades into grey, then into black. The rhythmic rocking of the surface vanishes as the water grows denser. The noise of the ship fades until only the sound of the hull remains, a steady groan as metal contracts under pressure. Communication weakens, voices blur, and soon the connection to the surface is reduced to a faint signal. For the crew, it's a technical experience, not an emotional one, yet the effect is unmistakable. The further they go, the more the ocean feels like another planet. And by the time they reach the trench floor, there's no sense of being beneath anything. It feels more like being surrounded by the absence of everything else. Isolation here is total, but not empty. The trench has its own version of presence, something dense and constant. The water isn't void, it's matter filling every possible space. The silence isn't lack, it's compression of vibration into stillness. Even time feels thicker. Because there's no sunrise or sunset, no motion fast enough to mark the passage of seconds, the human mind begins to stretch in response. Hours blur into long intervals without texture. It's not that time stops, it's that the brain has nothing to measure it against. Down here, isolation isn't a condition to endure. It's an atmosphere that defines reality itself. That atmosphere also shapes the behaviour of everything that lives in the trench. In a world without social structures, every creature operates alone. Amphipods scavenge without forming schools. Snailfish hover apart, sensing rather than seeing one another. Microbial colonies grow individually, linked only through chemistry. There's no need for cooperation because there's no abundance to share. Each organism moves within its own radius, guided by instinct honed over millions of years of solitude. This independence isn't loneliness, it's efficiency. The deep sea doesn't reward connection the way the surface does. Here, survival depends on self-containment. Still, when scientists study these creatures, they find traces of communication, chemical trails, vibrations, faint pulses of bioluminescence. Even in isolation, life seeks contact, though not in the ways we expect. The signals are slow and subtle, exchanged over hours or days rather than seconds. They're not conversations, not decisions, just acknowledgements of existence. It's a reminder that isolation is never absolute. Even here, beneath 8,000 meters of water, the impulse to connect remains part of life's design. The physical isolation of the trench mirrors a kind of scientific one as well. For most of history, our understanding of the deep ocean has been shaped by what we can't reach. The South Sandwich Trench, more than almost any place, represents that gap. Its location, so far south, so often hidden by storms, means that even with modern technology, only a handful of expeditions have studied it directly. The data we have is fragmented, scattered across decades. One expedition maps a section, another collects a few samples. Years pass between visits. The picture that emerges is incomplete but persistent, built piece by people who dedicate entire careers to understanding what others will never see firsthand. There's something solitary about that pursuit. It requires patience that borders on devotion, a willingness to work in partial light, trusting that the fragments will one day form a whole. The scientists who study the trench describe a peculiar emotional quiet that comes with their work. They spend months analysing numbers that represent conditions most humans will never experience. Pressure readings, temperature profiles, chemical concentrations. Each dataset is a faint echo from a place that exists outside normal perception. When they speak of isolation, it's not with melancholy but with respect. They know that their instruments are the only bridges to a world that doesn't need them. The trench doesn't change whether it's studied or ignored. It has no awareness of observation. That detachment gives their work a purity rare in other sciences. The deep ocean doesn't flatter curiosity. It simply endures it. It's tempting to draw parallels between this physical isolation and human experience, and there's some truth in the comparison. The deeper you explore the trench, the more it feels like a mirror held up to the mind's quieter corners. There's a similar stillness, a similar absence of distraction. Both the abyss and solitude force the observer inward. They remove context and leave only awareness. For some, that's unsettling. For others, it's clarifying. The South Sandwich Trench is, in a way, the purest expression of isolation that nature offers. A place where everything external has been stripped away, leaving only pressure and persistence. In that environment, existence itself feels distilled. When researchers play back recordings from the trench, what they hear is almost nothing. Long stretches of quiet interrupted by faint low frequencies. The ocean at that depth doesn't echo human activity the way shallower regions do. There are no propeller sounds, no seismic exploration blasts, no commercial shipping routes. The result is a soundscape nearly untouched by civilization. It's one of the last acoustic sanctuaries on Earth. In that sense, the trench is a kind of baseline, a reminder of what the planet sounded like before engines, before industrial noise, before our constant transmission of signals. The silence is not merely absence, it's a reference point for everything we've added since. That silence has measurable effects. Marine mammals in other parts of the world rely on sound to navigate and communicate. As human noise increases, their patterns change. Some species alter their calls, others abandon noisy areas altogether. The South Sandwich Trench, though nearly devoid of such life, serves as a control, a natural laboratory for understanding what unpolluted soundscapes mean for the ocean. The few whales that pass nearby likely hear it as a void, a gap in the otherwise constant hum of the world. It's the acoustic equivalent of a blank page, a rare space where nothing competes for frequency. Isolation also influences the geology itself. Because few disturbances reach this far south, the sediment layers accumulate slowly and evenly. Each layer records a snapshot of history undisturbed by human interference. The trench's floor is a timeline written in grains of silt, each one representing years of stillness. When core samples are extracted, they show a pattern almost hypnotic in its regularity. There are no abrupt gaps, no signs of upheaval. It's continuity made visible, proof that even in isolation, time never stops moving. The Earth keeps writing even when no one is reading. There's another kind of isolation at play here, the thermal kind. The waters that fill the trench are some of the coldest in the Atlantic, formed in the polar regions and sinking to the bottom as part of the global ocean circulation. Once there, they remain trapped for centuries, cycling slowly through deep channels before rising again far away. That means the water in the trench is older than any living person, perhaps older than entire civilizations. It has moved through the planet unseen, carrying with it the chemical traces of ancient climates. Studying its composition gives scientists clues about how the ocean stores heat, and carbon, how it regulates the atmosphere above. Even in its isolation, the trench participates in global balance. It's a silent partner in the climate system, influencing everything while remaining apart from it. For the few who have seen it directly, isolation becomes something tangible. When the lights of a submersible reveal the sea floor, there's no sense of landscape in the human sense. There are no horizons, no distances to measure. The visibility is limited to what the lights can touch, perhaps a few meters, maybe 10 at most. Beyond that, the world simply disappears. It's like being inside a bubble of awareness surrounded by infinite dark. The mind adjusts quickly, narrowing its focus, finding comfort in the small details. The movement of sediment, the drift of a tiny organism, the way the light fades at the edges of vision. In that narrowing, isolation becomes almost intimate. The observer and the observed exist in complete dependence for those few hours. What surprises many explorers is that the feeling isn't fear. It's not claustrophobia or panic. It's closer to calm. The mind recognizes that control is meaningless here. The environment is too absolute, too indifferent. The only choice is to observe and accept. For some, that acceptance feels like a kind of peace. There's no noise, no competition, no interruption, only the steady hum of existence under pressure. It's as if the trench has removed every unnecessary layer of experience, leaving behind only what matters most: presence without distraction. Isolation of this kind reveals something about connection too. The deeper we study the ocean, the more we realize that nothing on Earth is truly separate. The trench may be cut off from sunlight and sound, but it still participates in the planet's cycles. It exchanges heat and chemicals with the surrounding sea, records the movement of tectonic plates, and provides habitat for life forms that, in turn, influence global chemistry. Even in separation, there's interaction. The same could be said for people. True isolation rarely exists. We carry connection in the form of memory, thought, and history. The trench, in its way, holds memory too, of volcanic eruptions, of ice ages, of the slow rhythm of the Earth's breathing. It's solitude without absence. Scientists sometimes describe the South Sandwich Trench as a silent witness. It observes everything through accumulation. When a distant volcano erupts, ash particles eventually settle here. When the planet's magnetic field shifts, traces of that change are recorded in the iron minerals that line its slopes. When atmospheric carbon fluctuates, it alters the chemistry of the water that seeps into its depths. Over time, these small signals build a complete archive of Earth's shifting conditions. The trench, isolated though it is, becomes the most faithful record keeper imaginable. It remembers without judgment, without selection, without ever needing to act. And in that way, it mirrors us more than we might expect. Human isolation, when stripped of emotion, is also a form of observation. It's the condition in which awareness becomes most focused, when the noise of the world fades and the small details start to matter. The South Sandwich Trench shows what that looks like on a planetary scale. It's the Earth's consciousness turned inward, a place where everything unnecessary has been filtered out. What remains is pure observation, pressure balanced by silence, movement balanced by stillness. It's easy to romanticize that stillness, but the reality is neither comforting nor bleak. It simply is. The trench doesn't need company. It doesn't need validation. Its isolation is structural, not personal. That's what makes it so valuable to study. It offers a glimpse of nature unmediated by perception or intention. It's existence without narrative. For all our fascination with discovery, it's rare to find places that still exist in that state. Most of the planet has been named, mapped, and altered. The South Sandwich Trench resists all of that. It remains itself, unaffected by curiosity. And yet every time a probe descends or a sonar wave passes through, that isolation is momentarily breached. Information travels upward, breaking the silence. The data joins the global web of knowledge, connecting the trench to satellites, computers, and minds around the world. In that instant, isolation becomes connection again. The process repeats endlessly. Silence interrupted by inquiry, then restored. It's a rhythm as steady as the tides, though measured in years instead of hours. Isolation, then, isn't just an environmental feature of the trench. It's part of its identity, part of the balance that allows it to exist as it does. The creatures that live there embody it, the water enforces it, and the planet preserves it. To study that isolation is to understand not just the deep ocean, but something fundamental about the world itself. That separation and connection are not opposites, but phases of the same cycle. The trench isolates energy and information so that life and matter elsewhere can flow freely. Its stillness allows motion above. Its silence gives contrast to sound. Its darkness preserves light. Far above, storms cross the Atlantic, continents shift, ice melts and reforms. None of it reaches the trench in any immediate sense, and yet over time, every one of those events leaves its trace there. Even isolation has limits. The deep receives everything eventually. The dust of volcanoes, the chemicals of rivers, the microscopic remnants of human activity. They all sink, slow and patient, joining the sediment at the bottom of the world. Isolation, no matter how complete it seems, is never final. The ocean reminds us that connection always finds a way, even through pressure, darkness, and silence. Somewhere in that still water, between isolation and connection, the planet holds its breath. The trench waits, not as an empty void, but as a part of the Earth's living system, recording every distant echo. Each movement above sends a ripple below. Every vibration becomes part of its quiet archive. The isolation isn't loneliness, it's attention, and through that attention, the trench continues to exist exactly as it should, unseen but indispensable. And just beyond that silence, where the deep begins to tremble and the temperature shifts again, heat rises from the cold seafloor. Isolation gives way to activity, stillness gives way to motion, and the story of the South Sandwich Trench turns toward its next paradox. Volcanoes burning quietly beneath the coldest sea on Earth. Beneath the frozen stillness of the South Atlantic, beneath water cold enough to numb metal, there are fires that never go out. The South Sandwich Trench doesn't just mark the place where one plate dives under another, it's also where the planet exhales. Deep below the floor of the ocean, in the layer where crust melts into mantle, the pressure and heat combine to form magma. That magma rises through cracks and fractures until it finds release. The result is a chain of volcanoes that burns quietly beneath the most inhospitable sea on Earth. To imagine fire in such cold seems contradictory, but that's how the planet works. Contradictions held in perfect balance. The South Sandwich Islands are the visible peaks of that balance. They're the upper edges of a long volcanic arc formed by subduction, a line of mountains that pierce the ocean surface in a world of storms and ice. Each island is a volcano, some dormant, some active, all shaped by the same process that carved the trench beside them. Beneath the surface, the arc continues unseen, a string of submarine volcanoes stretching for hundreds of kilometers. Some of them have never been mapped, their existence known only through faint signals, small tremors recorded by seismographs, or changes in water chemistry hinting at hydrothermal activity. The region's remoteness keeps it hidden, but what little data we have shows that this is one of the most active volcanic zones in the Atlantic. To understand these volcanoes, you have to start far below them. As the South American plate slides beneath the South Sandwich Plate, it carries water and sediments deep into the mantle. At certain depths, the heat and pressure force the water out. When the water mixes with solid rock, it lowers the rock's melting point, creating pockets of magma. That molten material, lighter than the surrounding rock, begins to rise through the crust. Some of it cools before reaching the surface, forming solid intrusions of new rock. Some makes it all the way up, erupting as lava on the ocean floor. Over time, repeated eruptions build underwater mountains, which sometimes grow tall enough to form islands. That process is still happening today, quietly, continuously, under thousands of meters of water. From orbit, the South Sandwich Arc looks like a curved scar at the edge of the Atlantic. The islands themselves, Montague, Saunders, Bristol, Bellingshausen and others, form a line that matches the trench's curve exactly. Each sits above a magma source, each one fed by the same deep processes. Satellite observations show that several of these volcanoes are active, venting gas and heat, even through the thick layers of ice and cloud that often cover them. Mount Michael, on Saunders Island, is one of the most remarkable examples. It contains a persistent lava lake, one of only a handful known on Earth. That lake has been active for decades, maybe longer, glowing red under the Antarctic storms, a pocket of permanent heat surrounded by freezing ocean. It's a paradox in motion, a window into the planet's core, flickering inside a world defined by cold. The volcanoes beneath the water are harder to study, but they're no less dramatic. Instruments placed along the trench's slopes have recorded temperature spikes and chemical anomalies, signs of hydrothermal vents. These vents form where seawater seeps down through cracks in the crust, gets heated by magma, and rises again carrying dissolved minerals. When it emerges into the cold ocean, those minerals precipitate, building chimneys of metal sulfides that can grow several meters tall. Around those chimneys, entire ecosystems form, powered not by sunlight, but by chemistry. Microbes convert hydrogen, sulfide, and methane into energy, creating the foundation for food webs that include worms, crustaceans, and even small fish. It's life built from stone and fire, flourishing in total darkness. No one has seen the hydrothermal fields of the South Sandwich Trench directly yet. The pressure and remoteness make exploration nearly impossible. But scientists know they must exist. The pattern is universal. Wherever there's subduction, heat, and seawater, there are vents. They're like the planet's pores, releasing heat from within while recycling minerals back into the ocean. In the Pacific, these systems have been studied for decades, revealing species found nowhere else on Earth: giant tube worms, eyeless shrimp, and bacterial mats that shimmer like silver. The South Sandwich vents are likely similar, but colder, slower, and perhaps even more extreme. If we could see them, we'd be looking at one of the purest forms of Earth's internal processes: magma meeting ice, chemistry creating life, energy transferring from the core to the crust to the sea. Volcanic activity also explains the shape of the islands and the trench. Every eruption adds material to the overriding plate, building the arc upward. At the same time as magma rises and solidifies, it pushes against the surrounding crust, causing earthquakes that reshape the seabed. The entire region is in motion, rising, sinking, bending. Some eruptions happen quietly beneath kilometers of water, their lava cooling instantly into glassy rock. Others break the surface, sending ash into the sky and lava down the slopes into the sea. In satellite images, discoloured plumes sometimes appear in the water near the islands, evidence of recent activity. These plumes contain fine volcanic ash and chemicals that change the water's colour for days or weeks. It's the ocean's way of signalling what's happening below. The idea of volcanoes under ice may seem alien, but it's common in the southern oceans. The combination of subduction and cold creates some of the most unusual geological environments on the planet. When lava erupts under pressure and near freezing temperatures, it forms unique structures called pillow basalts, rounded, bulb-like shapes that resemble clusters of frozen bubbles. They cool so quickly that their outer surfaces solidify almost instantly, trapping heat inside. Over time, they build mounds and ridges across the seafloor, adding texture to the otherwise smooth trench walls. These formations, discovered through sonar mapping, tell a story of countless eruptions hidden from sight, each one contributing quietly to the slow evolution of the landscape. One of the most striking aspects of these volcanoes is their stability. Despite the cold, despite the pressure, their heat endures. Deep within the crust, magma chambers maintain temperatures of more than 1,000 degrees Celsius. That heat moves upward slowly, melting ice, warming sediments, and driving chemical reactions that sustain life. In some areas, small pockets of warmer water have been detected, oases of relative comfort in an environment otherwise near freezing. These temperature gradients create diversity. Different species gather around the warmer zones, forming tiny ecosystems amid the vast emptiness of the trench. Even in the coldest sea, warmth finds a way to shape life. The presence of these volcanoes also affects the chemistry of the ocean on a planetary scale. When volcanic gases and minerals enter seawater, they react to form compounds that influence the global carbon and sulfur cycles. Over geological time, this exchange helps regulate the atmosphere above. The trench, though isolated, participates in that cycle through its hidden volcanoes. Their eruptions release carbon dioxide, but they also create minerals that capture it again. The balance is delicate, yet it's part of the self-regulating system that keeps the planet stable. Every plume of ash, every vent of gas, every quiet eruption contributes to that invisible equilibrium. There's another dimension to this volcanic activity that connects to the larger history of the Earth. Submarine volcanoes like those in the South Sandwich region are thought to resemble the conditions of early Earth, when the atmosphere was thin and the oceans were rich in minerals. Back then, hydrothermal systems may have provided the first chemical energy for life to emerge. The combination of heat, water, and reactive minerals could have sparked the synthesis of organic molecules. Studying the modern equivalents helps scientists test that idea. The South Sandwich vents, cold and remote as they are, might hold clues to how life began not just in the ocean, but on the planet itself. If similar processes occur elsewhere, in the subsurface oceans of Europa or Enceladus, then these volcanoes beneath the cold Atlantic are also models for life beyond Earth. It's a strange thought, that something so distant and hostile could be connected to our origins. Yet the evidence is persuasive. The minerals formed at hydrothermal vents, iron, nickel, sulfur, are the same elements found in the cores of living cells. The energy gradients between hot and cold water mimic the gradients used by metabolism. Even the microbial communities that thrive there bear resemblance to the oldest fossils we've ever found. The deep sea and the volcanoes that feed it aren't just features of geology. They're archives of biology, reminders of where the story began. For researchers, reaching these environments is a test of technology and endurance. Unmanned probes designed for extreme conditions must withstand not only pressure, but heat. Their sensors need to function in chemical environments that would corrode metal within hours. The data they bring back, temperature readings, chemical signatures, images of mineral structures, are our only glimpses of a world that exists beyond direct experience. Each measurement is a fragment of a larger picture, a puzzle slowly being filled in. The more we learn, the clearer it becomes that the boundary between geology and biology is thinner than we thought. The volcanoes in the cold blur that line completely. On the surface, the South Sandwich Islands tell the same story in visible form. When an eruption occurs, the ash often settles over snow, staining it grey or black. Meltwater carries minerals down into the sea, where they mix with the cold currents. Even in satellite photos, these streaks are visible. Dark trails across white ice, signs of the planet's internal heat breaking through its frozen crust. Sometimes plumes of steam rise from cracks in the ice where geothermal energy escapes. In those moments, the region looks less like Earth and more like a preview of another world, a place where fire and frost coexist. The interaction between volcanic heat and polar cold also affects weather. The rising heat from eruptions creates localized convection, disturbing the stable layers of air above the islands. This can generate small, temporary storm systems that influence regional patterns. It's a reminder that even isolated volcanoes can shape the sky. On a larger timescale, volcanic eruptions contribute particles to the upper atmosphere, where they reflect sunlight and temporarily cool the planet. Some of those effects begin right here, in the far South Atlantic, where the world's coldest ocean meets its quietest fire. The volcanoes also influence the soundscape of the deep. When magma moves or gas escapes, it creates low-frequency vibrations called harmonic tremors. These signals can travel for hundreds of kilometers through the water. Hydrophones placed near the trench have detected them. Long, steady tones that resemble the hum of distant engines. They're the planet's voice, a slow murmur from within. Each tremor tells scientists about the movement of magma, the build-up of pressure, and the rhythm of the Earth's breathing. Even in silence, the ocean is full of these hidden frequencies, the language of the planet's inner heat. Despite the inhospitable environment, these volcanoes and their vents form small pockets of stability. Life clusters around them, using heat and chemistry as anchors. Some species may migrate from one vent field to another, carried by currents over years or decades. Others remain fixed, forming colonies that last for generations. It's a form of persistence that mirrors the planet's own cycles. Slow, patient, continuous. The volcanoes don't erupt constantly, they pulse. Each eruption reshapes the local terrain, covers old vents, and opens new ones. The ecosystems adapt, shift, and begin again. The result is a landscape always changing, yet always alive. When viewed from the perspective of geological time, these volcanoes are part of a much larger pattern. Subduction zones around the world follow similar rhythms. Magma rises, crust melts, trenches deepen, islands grow and erode. The South Sandwich system is one of the youngest, still finding its balance between destruction and creation. In a few million years, the positions of its islands will shift. Some may sink, others may rise. The trench will migrate eastward as the plates continue their slow collision. The volcanoes in the cold will persist through all of it, feeding the ocean, shaping its chemistry, reminding us that even in the most remote corners of the planet, energy never stops moving. There's a quiet irony in the fact that the most active part of the Atlantic lies beneath one of its most silent. From above, the region looks static, a grey expanse of storm and ice. But below, heat moves constantly, carving new pathways, building new mountains, releasing minerals into the sea. The South Sandwich Trench is not just a passive scar on the ocean floor, it's a dynamic boundary, alive with motion. Its volcanoes are proof that even the coldest, most isolated parts of the world are connected to the Earth's core, to the same fire that once shaped continents. And as the heat continues to rise, the trench itself responds. Earthquakes ripple through its walls, sediments shift, the chemistry of the water changes. Everything is in dialogue, even if the conversation unfolds over millennia. The volcanoes in the cold are part of that conversation, speaking in eruptions and vents, in minerals and gases, in slow transformations that humans can only measure, not witness. If you were to descend again now, past the silence, past the pressure, you might see faint plumes rising from the seafloor, ghostly columns of shimmering water marking the vents. Around them, you'd find movement, tiny creatures clinging to the warm rock, mineral particles swirling like dust in light. The contrast would be almost impossible to comprehend. Ice-cold water touching molten heat, darkness glowing faintly from within. It's the closest thing we have to seeing the Earth's heartbeat, and somewhere above those quiet volcanoes, in the darkness just beyond their reach, the trench curves onward, disappearing into shadow. The heat fades into cold again. The light dissolves into blackness, and the ocean returns to stillness. But the balance remains. Fire beneath ice, heat beneath silence, creation beneath pressure. The trench endures because it contains them all. And beyond its volcanic heart lies the next truth about it. The realization that even in such a remote, forbidden place, the trench is not separate from the rest of the planet at all. It's part of a greater system, the unseen engine that links oceans, continents, and air in one continuous motion. For most of human history, the Atlantic Ocean has been a highway. It carried explorers, traders, migrants, and armies. Its surface has been measured, mapped, and crossed countless times, yet its depths have remained almost invisible. The South Sandwich Trench, sitting far at the edge of the Atlantic's reach, is one of those few places that remind us how incomplete our understanding still is. It's the frontier we don't talk about, not because it's irrelevant, but because it lies beyond comfort, beyond utility, beyond the range of most human imagination. When people think of the unknown, they often look outward towards space. But if the ocean were reversed, if its trenches rose upward instead of sinking down, they would tower higher than Everest, their peaks hidden in permanent cloud. The Atlantic's greatest frontier is not above us, it's beneath us. Every ocean has its limits, but the Atlantic's isolation is different. The Pacific is vast, open, and filled with arcs and ridges that have been studied for decades. The Indian Ocean is encircled by trade routes. The Arctic is defined by ice and seasonal change. The South Atlantic, by contrast, feels forgotten. Its southern extremes are not on the way to anywhere. No shipping lanes cross the South Sandwich Islands. No coastal nations claim the trench as their own. It sits in a kind of geopolitical silence, too far for casual exploration and too deep for practical resource extraction. In a world that measures value by accessibility, it has none. And yet, because of that, it remains one of the last truly untouched places left. The irony is that we know more about the surface of Mars than we do about this part of the Atlantic. Satellite data has mapped every major landform on the red planet, but only a small fraction of Earth's seafloor has been charted in detail. This South Sandwich Trench lies among the least studied regions of all. Its exact contours are known only from sonar passes made by a handful of research vessels. Even those maps show gaps and distortions, sections where instruments lost contact or waves made readings unreliable. Each new expedition adds detail, but most of what we know comes from extrapolation. Between the known lines, there's still room for discovery. To understand what makes the trench the Atlantic's secret frontier, you have to consider what it represents. It's not just a geological feature, it's the edge of a system, the dividing line between one plate and another, between the familiar and the unknown. When you look at a map of the ocean floor, the trench forms the boundary where the South American plate dives beneath the small South Sandwich plate. This process is ongoing, reshaping the planet every day, yet invisible to us. The forces involved are immense, but they operate at a scale too slow for human perception. The frontier, then, isn't just physical, it's temporal. It's where time moves differently, where change takes millennia instead of moments. Every measurement taken here reveals something about the Atlantic as a whole. The trench records the stresses of the Earth's crust, the flow of deep water, the movement of heat and minerals. It's a focal point where many of the planet's systems converge quietly. If we could observe it continuously, it would act as a kind of mirror, reflecting the global balance of energy and motion. But we don't. We glimpse it briefly, through a dive or a sensor, and then it disappears again into distance and pressure. It remains what it has always been, a frontier defined by its absence. That absence extends beyond science. There's a cultural invisibility to this part of the ocean. Maps of the Atlantic tend to emphasize the north, the busy lanes between continents, the history of exploration, colonization, and commerce. The southern reaches are blank spaces named but rarely pictured. The South Sandwich Trench doesn't appear in textbooks, documentaries, or popular imagination. It has no myth, no story attached to it. The Mariana Trench has the drama of being the deepest. The Tonga Trench has its seismic power. The South Sandwich Trench is quieter, hidden behind geography and indifference. Yet its very obscurity makes it significant. It's the test case for what happens when nature is left alone, long enough to remain itself. In the absence of industry and habitation, the trench offers a glimpse of an ecosystem unaffected by direct human interference. The life that exists there has evolved without light, without heat, without noise. It's not pristine in the romantic sense. Microplastics and chemical traces still find their way even here, but it's as close as we have to an unaltered environment. That makes it invaluable for science. By studying how the trench functions in isolation, researchers can understand how natural systems operate when left undisturbed. It's the baseline against which all other data can be measured. In that way, the trench isn't just a frontier of geography, it's a frontier of knowledge, defining the limits of what we still need to understand. The few who have studied it closely describe a sense of humility that's hard to communicate. Standing on the deck of a ship above 8,000 meters of water, surrounded by fog and wind, you realize how thin the human layer of the planet really is. All our cities, our communication networks, our history, they occupy a fragile film above an enormous indifferent depth. The trench represents that depth in its purest form. It's a reminder that most of Earth's volume lies beyond direct reach. The frontier is not something we conquer, it's something we acknowledge. Even technologically, the trench remains a boundary. The submersibles and probes that visit it operate at the edge of their capabilities. Every descent tests materials, electronics, and design principles. The pressure leaves no margin for error. The remoteness means that recovery is uncertain if something fails. Each mission requires weeks of preparation and coordination. Data must be transmitted through thick layers of water where signals weaken or distort. The cost and risk ensure that only a few such expeditions happen in any decade. The frontier endures because the challenges are built into its nature, yet it continues to draw attention precisely because of those challenges. There's something irresistible about a place that refuses to yield easily. The South Sandwich Trench is the kind of mystery that keeps science grounded. It reminds us that not everything can be solved from orbit or simulated in a lab. Some truths require proximity, even if that proximity is brief and difficult. Each time we return, we discover not just facts but perspective. The trench teaches us scale, the difference between our time scale and the planet's, between what we call extreme and what Earth calls ordinary. For all its inaccessibility, the trench is not irrelevant. It connects directly to global systems. The subduction zone beneath it generates earthquakes that can be felt as far as the Falkland Islands. It contributes to the deep ocean circulation that helps regulate temperature across the Atlantic. Its sediments store carbon, locking away the remains of life from the surface. The volcanoes along its arc release gases that influence ocean chemistry. In these ways, the trench participates in the same cycles that sustain everything above. The frontier, hidden as it is, supports the familiar world indirectly. Its silence is part of the planet's equilibrium. That's what makes the South Sandwich Trench so fascinating. It's both remote and integral, isolated and essential. It's a paradox that defies simple classification. From one perspective, it's the least relevant place on Earth, inhospitable, unreachable, uninhabited. From another, it's the foundation of balance, the deep mechanism that allows the ocean to function as a system. It doesn't need to be seen to matter. The Atlantic depends on it in ways that surface life never notices. The concept of a frontier usually carries connotations of exploration and expansion. But in the case of the trench, the frontier isn't about movement outward, it's about recognition inward. The secret frontier of the Atlantic is a mental boundary as much as a physical one. It challenges our assumption that discovery always involves arrival, that knowing means possessing. The South Sandwich Trench can be mapped, sampled and studied, but it can't be occupied or owned. It exists in defiance of ownership. It's the part of the world that belongs to itself. The more scientists learn about it, the more it reshapes our definition of discovery. In the early days of oceanography, the goal was to find and categorize, measure depths, identify species, plot geological features. Now the emphasis has shifted to understanding relationships. The trench fits perfectly into that evolution. Its importance lies not in what it contains, but in how it connects. It's where the surface world meets the interior, where water touches rock, where biology overlaps with geology. It's a zone of exchange, not isolation. The frontier is not a wall, it's a bridge. In recent years, there's been talk among researchers of establishing long-term observation stations in the South Sandwich region. Arrays of sensors anchored to the seafloor to record pressure, temperature, and seismic activity continuously. Such projects would turn the trench from a distant curiosity into an ongoing source of data, a permanent ear pressed to the planet's heartbeat. The challenge, of course, is maintaining those instruments in a place so remote and hostile. Power, communication and maintenance all become nearly impossible at that depth. But the idea persists. The frontier invites attention even when it resists it. There's a certain poetic irony in how the Atlantic's most inaccessible place has become a symbol for understanding the whole. In an age when satellites orbit every hour and data flows constantly, the trench reminds us that knowledge still has limits. It exists as a quiet counterpoint to the illusion of total awareness. No matter how advanced our instruments become, there will always be places where information moves slower than curiosity. The South Sandwich Trench is one of them, a reminder that mystery isn't an obstacle to understanding, but part of it. If you stand on a research vessel above that part of the ocean, the frontier feels more like an absence than a location. The horizon stretches unbroken. The sea and sky merge in grey continuity. There are no landmarks, no sounds beyond wind and water. Beneath that monotony lies one of the planet's most complex environments, hidden under pressure that no human body could endure. That contrast, the simplicity of the surface and the complexity below, is what defines the Atlantic's secret frontier. It's the meeting point between what we know and what we can only infer. For now, the frontier remains secure in its obscurity. Few ships visit. The currents guard it with cold, the weather with violence, the depth with physics. Its secrets are safe not through intention but through natural defense. And perhaps that's for the best. Every frontier benefits from distance. The trench's remoteness allows it to remain a measure of what's still wild, still beyond manipulation. In a world increasingly altered by human hands, such places are becoming rare. The South Sandwich Trench endures because we can't easily reach it. Its inaccessibility is its preservation. Still, its influence travels. The data gathered from it shapes models of climate and geology. The discoveries of its life forms inspire research into medicine and materials. Its existence fuels imagination and humility alike. The secret frontier gives back knowledge without surrendering itself. It remains, quietly, the hidden foundation of the Atlantic, the unseen mechanism beneath the surface order. Somewhere in that vast grey water where storms break and rebuild endlessly, the trench continues to do its work. It receives sediment, processes heat, balances motion. It's not waiting to be discovered. It's simply continuing, indifferent to attention. But for those who know where to look, it marks the end of one kind of world and the beginning of another. The line where sunlight dies is not an ending. It's the threshold of everything still unlearned. And beyond that threshold, deeper still, lies the core of the Atlantic's energy, where all these forces converge into rhythm, the deep pulse of the Earth itself. The trench is more than a frontier. It's the hidden link that connects the planet's surface to its heart. It's there that we begin to see the pattern behind it all, the constant movement, the quiet balance, the pulse that never stops. The South Sandwich Trench might seem like a remote crease at the edge of the Atlantic, but its movements echo through the planet. It is one of the many places where the Earth breathes, where the planet's inner forces meet the outer world in a constant exchange of energy. When we talk about the pulse of the planet, we usually mean something poetic. But in a geological sense, the planet truly does have one. It beats in patterns of heat, pressure and motion. It's slow, deeper than any biological rhythm, but it's constant. The South Sandwich Trench is one of the valves through which that rhythm can be felt. Every part of the planet participates in this pulse. The crust shifts and bends, the mantle convects, the core spins faster than the surface. Heat from radioactive decay deep below pushes outward, while sunlight and atmosphere press inward. Between those forces lies balance. The planet's pulse is not a metaphor. It's the measurable vibration of equilibrium, the slow redistribution of energy that keeps the system alive. The trench plays its part by recycling the crust. As one tectonic plate dives beneath another, rock that was once at the surface is dragged downward into the mantle, where it melts and mixes with deeper material. That process removes heat, releases gases, and maintains the dynamic that allows continents and oceans to exist. Without subduction zones like the South Sandwich, the Earth would stagnate. The crust would thicken, the heat would build, and the cycle of renewal would stop. When scientists monitor the trench, they're listening to that planetary pulse. They use seismographs to record tremors, hydrophones to detect low-frequency sound waves, and pressure sensors to measure subtle deformations of the seafloor. Each reading is a heartbeat, a record of energy moving through rock and water. The data reveal rhythms on multiple timescales. There are daily pulses, tiny changes caused by tides. There are monthly ones linked to lunar gravity, and there are slow, irregular beats caused by earthquakes, volcanic eruptions, and shifts in mantle convection. Together, they form a living pattern, complex but steady, that defines how the Earth functions as a single organism. If you could translate those signals into sound, it wouldn't resemble music in any familiar sense. It would be a series of long, low rumbles separated by intervals of near silence. Some vibrations would last for seconds, others for days. The frequencies are below the range of human hearing, but they exist, passing through rock and water continuously. In a way, the trench acts as a stethoscope pressed against the Earth's interior. The deep ocean amplifies the low frequencies, allowing them to travel far. Some of these waves can be detected thousands of kilometers away, crossing entire oceans without losing strength. They carry information about the planet's structure, temperature, and movement. To listen to them is to hear the slow language of geology. The pulse is not uniform, it varies with time and place. In the South Sandwich region, the rhythm is shaped by the meeting of plates and the presence of active volcanoes. The subduction zone here is steep, which means the descending plate sinks rapidly, generating deep earthquakes. Some of these are so powerful that their energy travels around the world. They're recorded by instruments on every continent. When one occurs, it's as if the planet takes a breath, flexes, and then settles again. The surface might shake for a few minutes, but the internal oscillations continue for hours or even days. These long-period waves are known as free oscillations. They cause the entire planet to vibrate like a bell after it's struck. The trench is one of the points where that vibration begins. On a smaller scale, the pulse shows itself in hydrothermal activity. The vents along the volcanic arc release heat in cycles, sometimes constant, sometimes intermittent. Temperature sensors placed near them record fluctuations that mirror the movements of magma below. When magma rises, the water warms. When it cools or solidifies, the heat output decreases. The pattern can repeat over years or decades, depending on the dynamics of the magma chamber. These thermal pulses affect the surrounding chemistry, influencing what kinds of life can thrive there. The microbes near the vents are, in a sense, living on the heartbeat of the Earth, their existence tied to its rhythm. What's fascinating about this system is that it connects every scale of existence. The pulse that moves through the mantle also affects the surface climate over time. Volcanic gases released by eruptions alter atmospheric composition. The carbon dioxide that escapes from magma eventually becomes part of the air we breathe. The heat that escapes from the crust drives circulation in the deep ocean, influencing how nutrients and oxygen are distributed. Even the smallest tremors send energy into the water, where it disperses as sound. The pulse is not confined to geology, it reaches into biology, chemistry, and weather. Every living thing on the planet, directly or indirectly, feels its rhythm. When oceanographers speak of the deep ocean circulation, they often describe it as the planet's bloodstream. It carries oxygen, carbon, and heat from one part of the world to another. That flow begins, in part, near the South Sandwich Trench. The cold, dense water of the Southern Ocean sinks here and spreads northward along the seafloor, eventually rising again thousands of kilometers away. This movement takes centuries to complete a full cycle. It's one of the slowest processes on Earth, yet it's vital. Without it, the surface waters would lose oxygen, temperatures would become unstable, and ecosystems would collapse. The trench helps set that motion in place, channeling water downward as the crust moves beneath it. It's another form of the pulse, one that moves not through rock, but through the sea itself. The concept of a planetary pulse isn't new. Early geologists noticed patterns in earthquakes and volcanic activity long before they understood plate tectonics. They spoke of the Earth as a living being, with convulsions and respiration. The language was metaphorical, but it captured a truth that modern science has confirmed. The planet does operate like a living system, with feedback loops and self-regulation. The South Sandwich Trench is a critical node in that network. It's where the Earth's internal heat is released in a controlled way, maintaining balance between creation and destruction. Each earthquake, each eruption, each tremor contributes to that regulation. They're not random events. They're expressions of equilibrium. The pulse of the planet can also be observed in the magnetic field. The movement of molten iron in the outer core generates currents that create the field protecting Earth from solar radiation. Those movements are influenced by the distribution of heat within the mantle and crust. Subduction zones like the South Sandwich Trench help drive that distribution. By carrying material downward, they help cool the mantle, which in turn affects the flow of the core. The magnetic field, which seems so distant from geology, is connected to it through this deep cycle. Every shift in the trench, every release of heat, contributes indirectly to the stability of the field that shields the surface. When viewed over geological timescales, the pulse becomes more complex. The planet's rhythms operate in layers, daily, annual, millennial, and beyond. Over millions of years, the movement of plates rearranges continents and oceans. The South Sandwich System itself is temporary. It will continue for perhaps tens of millions of years before changing configuration. The arc of islands will shift, merge, or erode, and the trench will migrate. But while the features change, the pulse remains. It's not tied to one location. It's the underlying dynamic of a living planet. If you think of the Earth as a body, then the oceans are its lungs. They absorb carbon dioxide, release oxygen, and moderate temperature. The trenches, in that analogy, are the deep veins where circulation sinks inward. The South Sandwich Trench draws surface material downward, recycling it into the mantle, just as veins carry blood back to the heart. It's a slow process, but the comparison holds. The planet's health depends on it. Without these deep conduits, the atmosphere would fill with excess gases, and the surface would become uninhabitable. The trench's invisible work helps sustain the conditions that make life possible far above it. Scientists studying the global carbon cycle have traced part of that pulse directly to subduction zones. When organic material sinks into the deep ocean, much of it eventually gets buried in sediments along trench walls. Some of it is carried down with the subducting plate, sequestered in the mantle for millions of years. Later, volcanic eruptions release it again in the form of carbon dioxide, completing the loop. It's a long, slow respiration, the planet inhaling and exhaling over geological time. The South Sandwich Trench participates in that cycle as one of the lungs of the Earth. Its quiet depths are part of the reason the atmosphere above remains balanced. Even the smallest events here can ripple outward. A minor earthquake can trigger landslides that send clouds of sediment drifting across the sea floor. Those particles affect local currents, scattering light and nutrients. The changing conditions alters microbial activity, which in turn influences chemical balances. A single geological pulse can cascade into biological responses that last for years. On human timescales, such effects are invisible, but in the slow rhythm of the planet, they're part of the ongoing pattern of adaptation and response. One of the most fascinating discoveries in recent years is that the pulse of the planet can actually be measured as a vibration in the atmosphere. When a large earthquake occurs, it doesn't just shake the ground. It sends pressure waves upward, through the ocean, into the air, and even into space. Satellites have detected these signals travelling through the ionosphere. The Earth's internal motion communicates with its outermost layer. The planet's heartbeat resonates all the way to the edge of space. The South Sandwich region, with its frequent seismic activity, contributes to that symphony regularly. Each quake sends a pulse that moves from the depths to the atmosphere, a reminder of how tightly connected all layers of the planet truly are. For those who study it, the trench becomes more than a scientific subject. It's a kind of meditation on scale. Standing above it, listening to the low frequencies of the planet's movement, you realize that the rhythms we live by, days, years, lifetimes, are only surface patterns. The deeper rhythms operate over spans so vast that they seem still, but they are not. The planet's pulse is continuous. It has never stopped since the Earth formed 4.5 billion years ago. It's the sound of the core turning, the mantle flowing, the crust shifting, the oceans circulating. The South Sandwich Trench is just one of its countless instruments, but its tone is deep and steady. There's a tendency to think of the deep ocean as separate from us, a place that exists outside daily life. But the trench's pulse is felt indirectly in everything. The weather, the tides, the stability of continents, even the chemical balance of our bodies. The calcium in our bones once circulated in seawater. The oxygen we breathe was balanced by oceanic processes that depend on deep circulation. The rhythm that sustains us began long before we did, and will continue long after. The South Sandwich Trench is a small part of that continuum, yet it embodies it completely. The pulse of the planet doesn't need an audience. It would continue even if no one measured it. But listening to it changes how we see the world. It shifts perspective from human urgency to planetary patience. In that patience lies resilience. The Earth has endured countless changes, impacts, ice ages, extinctions, and through it all the pulse has never ceased. It adapts, slows, accelerates, but it remains. The South Sandwich Trench reminds us of that continuity. Beneath the storms, beneath the cold, the rhythm continues, steady and calm. If we could visualize it, the heat rising, the plates moving, the water cycling, it would look like a slow, endless breath. Expansion and contraction, release and absorption, silence and motion. The pulse is the thread that connects every layer of the planet's system. It links magma to mountain, trench to atmosphere, microbe to mammal. To understand it is to see Earth not as a collection of parts, but as one continuous living structure. And as the planet continues its slow exhalation through the South Sandwich Trench, we find ourselves part of that same motion, standing briefly on its surface, breathing with it without realizing. The pulse travels through us too, in air and gravity and water, reminding us that the frontier below isn't separate from the world we inhabit. It's part of the same circulation, the same heartbeat that has always been there, waiting quietly beneath the waves. Somewhere in the black stillness beneath the ship, that pulse continues to travel through rock and sediment, through layers of water dense enough to crush metal. It moves unbroken, carrying the memory of eruptions and quakes, of the slow rise and fall of continents. It's the planet's signature, unchanged and unstoppable. And as it passes, it stirs the last section of the trench's story, the return to stillness, the reminder that all motion, no matter how powerful, eventually folds back into quiet. When the work is finished, when the instruments have been retrieved and the engines quiet, the ship drifts above the trench in darkness. There's no visible line marking the edge of the known and the unknown, no shimmer on the surface to show where the deepest point lies. It's just water, grey, flat and endless. The horizon dissolves into the night. The air carries salt and cold. The deck creaks softly as the ocean breathes around it. Above, the stars stretch in numbers that only appear this far from land. They seem closer, sharper, as if the atmosphere has thinned enough for space itself to show through. It's easy to forget that beneath that calm, just a few kilometers down, is a world of pressure and silence where the pulse of the planet moves slowly and steadily through stone. Looking upward, the sky feels infinite. Looking downward, the depth feels greater still. Between the two lies the thin layer of air and sea that sustains everything we know. The South Sandwich Trench, so far from the noise of the continents, becomes a kind of mirror for that realization. Everything above, wind, stars, light, feels distant from the reality below, yet connected by the same gravitational pull, the same physics, the same quiet laws that hold the world together. You begin to understand that isolation isn't emptiness, it's a form of clarity. In places like this, where nothing distracts, you see how small the line of human experience truly is. At the surface, the night is almost motionless. The ocean's texture smooths into long swells that move like breath. Somewhere below, those same waves send pressure pulses through the water that fade into the depth. They reach the trench's slopes and reflect weakly, merging with the background vibration of the earth itself. Everything is linked by motion too slow to feel. The stillness above hides the motion below, just as the silence below hides the heat within. The trench, even unseen, shapes what happens here. Its gravity affects local currents. Its presence alters the patterns of water density. Every ripple of the sea carries a trace of the void beneath. For the people who spend time studying it, there's a moment each expedition when they simply stand on deck and listen. There's nothing to hear, only the faint sound of wind and the distant creak of metal. But in that absence lies a sense of perspective that no laboratory can offer. The trench, the ship, the sky, the stars. Each belongs to the same continuum, operating at different scales of time and distance. The night sky above and the abyss below are opposites that meet in sensation. Both are vast, both are cold, both erase any sense of boundaries. To stand between them is to occupy a rare middle ground where you can feel the size of the planet without abstraction. Even with all the data collected, the sonar maps, the recordings, the samples, most of the trench remains unseen. The instruments measure what they can, but the ocean keeps its own language. Every reading we take is partial, every image incomplete. Yet the incompleteness isn't failure. It's the reason to keep returning. The point of studying places like this isn't to exhaust their mystery. It's to maintain the conversation between curiosity and patience. The trench teaches that the planet's truths aren't hidden from us. They simply exist at a pace we're not accustomed to following. The calm that fills this region isn't stillness in the ordinary sense. Beneath the quiet surface, there's motion everywhere. Currents slide along the trench walls, cold water sinking while slightly warmer layers rise. Sediments drift in slow clouds, settling and lifting again with each microquake. Chemical reactions continue invisibly inside rocks that have been under pressure for millions of years. Life persists in microscopic forms, reproducing and feeding, leaving traces in the mud. The stillness only exists at human speed. If you could compress time, watch 1,000 years pass in an instant, the trench would appear alive, shifting and breathing like the surface world. Stillness is an illusion of scale. The stars overhead move with equal patience. Their light left its source before the trench even existed, before the South Sandwich Arc began to form. By the time it reaches the sea tonight, continents have shifted, climates have changed, species have risen and vanished. The light arrives without hurry, unbothered by distance. It reflects faintly off the waves, bends through thin mist and disappears again into the blackness. That quiet shimmer connects the deep with the infinite. One burns, the other freezes, yet both share the same indifference to time. The stillness below the stars is not a pause between movements. It's the meeting point of two forms of motion so vast they cancel each other out. The scientists on board speak quietly, almost by instinct. Voices carry too clearly across the water, so conversation becomes a kind of whisper. Even laughter sounds subdued. The atmosphere feels more like a library than a ship. Each person seems to sense that they're in a rare alignment of elements. Ocean, sky, gravity and light, balanced for a few fleeting hours. Soon the work will continue, engines will start again, and the ship will move north. But for now, everything holds in equilibrium. The trench below and the stars above seem aware of each other, even though they never meet. In moments like this, the distinction between exploration and observation fades. There's nothing left to discover that would change the feeling of the place. The knowledge gathered so far already reveals what matters most, that the Earth is a system of cycles nested within cycles, that energy flows in every direction, that balance is never static. The trench is not the end of that system. It's one of its many expressions. To understand it is to understand that life and geology, silence and sound, motion and stillness, are parts of the same equation. When the first light appears at the edge of the horizon, it doesn't rise suddenly. It builds in gradients, grey turning to silver, then to a faint gold that spreads across the clouds. The stars fade one by one, absorbed into the daylight. The ship's deck grows damp with condensation. The ocean changes colour slowly, reflecting the sky's shift from black to blue. Nothing dramatic happens, yet everything feels transformed. The surface warms slightly. The wind adjusts. The first seabird appears from nowhere, circling once before vanishing again into the distance. In that transition, the trench remains unseen, unchanged, still silent. It doesn't notice dawn. It doesn't need to. Every expedition leaves this place knowing that it will remain the same long after they're gone. The South Sandwich Trench existed before our species learned to write, before cities, before ships. It will exist after. Its processes don't depend on attention. They continue whether or not anyone is watching. In that sense, it's a reminder of continuity that extends beyond human context. The trench doesn't carry memory in words, but in layers of sediment, in the chemistry of its water, in the slow accumulation of detail that forms the planet's true history. It remembers everything without intention. For those who visit it, the realization can be strangely comforting. The vastness doesn't diminish meaning, it clarifies it. The smallness of human life against such scale isn't humiliation, it's proportion. We are part of the same sequence of energy that drives the trench, the same thermodynamic pattern that forms galaxies, the same logic that keeps stars burning and oceans moving. The abyss beneath the Atlantic and the sky above it are not opposites. They're two sides of the same continuous system. In between them, we occupy a brief conscious interval. Sometimes, as the ship turns and begins its journey north, someone lingers at the railing. They watch the water slide past, knowing that 8,000 meters below, there's rock folding, heat rising, microbes living, sediments settling. They might not see it, but they can sense it, the weight of the planet, the quiet precision of its motion. They breathe the air, aware that the oxygen in their lungs once cycled through that ocean, that the carbon in their blood once belonged to ancient marine life, that the salt on their skin matches the minerals dissolving in the trench's depths. The separation between human and planet, between surface and core, becomes thin. The realization doesn't require philosophy. It's physical, direct, undeniable. The South Sandwich Trench is sometimes called the most forbidden abyss in the Atlantic, not because it hides danger, but because it resists domestication. It can't be crossed, conquered, or occupied. It exists outside ambition. It reminds us that not all knowledge is for control. Some knowledge simply asks for recognition. To know the trench is to accept its terms, to understand that it will always be deeper, colder, and more patient than we can imagine. That acceptance doesn't limit curiosity. It refines it. It turns exploration from an act of possession into one of respect. At night, when the sky clears completely and the Milky Way stretches across the southern horizon, the view becomes almost symmetrical. The stars above and the bioluminescent flashes of plankton below echo one another, two fields of light separated by distance but joined by pattern. The scale is unimaginable, yet the structure is the same. Clusters, voids, motion suspended in silence. The trench mirrors the sky not by appearance but by function. Both are vast, both are governed by laws beyond intervention, both hold within them the story of everything that has ever existed. To look up and then down in this place is to see continuity in opposite directions. If you could descend now through the cold and darkness, you'd find the same slow dance continuing, particles settling, water moving, rocks shifting imperceptibly, creatures drifting through beams of their own light, the heat from distant magma rising in faint plumes. It's not dramatic, not cinematic, but it's constant. That constancy is what makes it beautiful. The stillness below the stars isn't the absence of activity, it's the presence of perfect balance. The trench holds that balance effortlessly, without struggle or intent. It just is. Even after the ship leaves, the place remains. The waves close over the spot where instruments were lowered. The surface shows no sign of the work done below. Satellites pass overhead, recording temperature and cloud cover, but not the quiet heat exchanges happening 8 kilometers beneath. The data will continue to arrive in intervals, numbers that translate into graphs, models, papers. Yet none of them will capture the feeling of the place itself, this sense of being suspended between two infinities, one of light and one of weight. That feeling isn't data, it's understanding. Every generation rediscovers this truth in its own way. The explorers of the past saw it in deserts, mountains, and poles. Today we find it in the depths of the ocean. The frontier changes, but the lesson remains, that the world is larger than our ability to measure it, and that its most profound qualities often exist beyond observation. The South Sandwich Trench, silent and unseen, is a reminder that the universe doesn't need witnesses to function. It continues, with or without us, and that continuity is the quiet miracle that sustains everything. When the night closes again and the stars return, the cycle resets. The ocean glows faintly under starlight. The sky turns black enough that the edge between water and air disappears. Somewhere far below, the trench continues its patient exchange of heat and matter. The planet's pulse moves through it. The silence returns to equilibrium. And for a moment it's possible to feel that everything, air, water, rock, life, is part of the same slow, steady motion. The stillness below the stars isn't an ending. It's a continuation so smooth that beginnings and endings no longer matter. The ocean remains, the earth keeps turning, the trench holds its depth, the stars keep burning. And between them, briefly, we listen.